You've got to be creative when you're dealing with this type of energy. I only have this or I only have that, so what am I going to do? Am I just going to stand there and do nothing and say it doesn't work? Well, that's what most do. You know, but I'm not going to do that. See, I'm going to find a way to get the power out of something through whatever means I have to use to get it. Because after all, I don't have any energy now and the lights are up. I need to charge this battery.
Hello, everyone. I'm Old Man Builds. I'm here with Benefactor and our special guest today, Myke Does. All right, everyone. We're going to talk about the Bedini motor today. Awesome motor. We're going to talk about the circuits on it, and we're going to take a look at Myke's design and what he's got going on his. Myke, tell us a little bit about the motor you built.
It's just a Bedini motor, the standard one, SG, or are you talking about the most recent one? It's a little different, the other one.
Just the one that you told us about before. I know that we looked at together one that looked like the window motor we talked about with the standard different coil around it and the magnets in the middle. And the other one you talking about a wheel? Was it the bicycle wheel one?
Yeah, the one that I've replicated by Bedini is a standard Bedini SG. It looks like a bicycle wheel with magnets on it, and I can bring up the circuit right here. Let's see. Let me bring up the circuit here.
While he's bringing that up, guys, I'm excited about this because we have some energy spikes in here that I want to go over with Myke, and because he's built it, I want to see exactly what's going on in it. So
you can have it.
It's going to be really cool. Okay, here we go. Here's the circuit. Let's put it up there. What do we got going on?
So this is your standard Bedini SG pulse motor, sort of like, a pulse motor, but different, a little different. Which one is this? Oh, hold on. I brought up the wrong one. Let me see. Okay. I'll bring one off the. Let me bring up the right one. Hold on.
Oh, bring it in. We'll check it out.
It looks like this is the non-solid state one, right? The little moving coil.
GSG. Okay. See, there it is. Okay, that's the one.
That's the one. Okay.
So that's the basic circuit. See here. Okay. You can see the blue marking. Okay. Yeah. So here's your source battery.
Okay.
And here's the charging battery.
Charging battery. Okay.
And this is the coil that you're going to charge up from your source battery. And when, the transistor closes, it'll charge up.
We're using PNP or NPN?
It's NPN.
Explain to the audience the unique situation where the diode is actually feeding negative energy.
This diode?
Yeah, isn't it feeding it backwards into the battery?
Yes. So let me explain that.
Yeah, that's fascinating.
This is not, you could be a technician or whatever. Unless you fully did the research before you built this, you're probably not going to understand what's going on. So what happens is the coil receives a plus right here from your battery, from the charge battery, right? See it? This is your plus from your charge battery.
Okay.
Okay. And it will place itself right here on the coil. Plus, right? And then the negative will when this transistor gate closes, the negative will appear on the other side of the coil, right here, because it's over here, right? And now you're placing a negative and a positive on this coil.
Hold on. How did it get the negative through the switch?
Oh, because you triggered the transistor to close the gate and allow the negative in. So let me go back a little bit. So this is the base of the transistor here. And this is the trigger winding, right?
Yes.
Which is like a gauge 28, a little thinner. This is like 26 right here, about 150 feet of each.
Are they separate? I thought they were
no,
wound together.
They're wound together.
Okay.
When you say trigger wire, is that the pickup wire or the wire that you're inducing with?
Yes, they're wound together. Both these are wound together in a bifilar.
Oh, that's right, they're bifilar.
Right, so this magnet here, when it ends up around here, it's going to, and there's a core inside here, iron core. So it will, when this magnet ends up around here, it will charge up really both the coils, with magnetic field from the magnet. But the only coil that's going to matter, this is that magnetic field from the rotor magnet hitting this coil is not going to do anything because it's just not going to, but it's going to hit this coil, also, and give it about 2 volts, and it's going to send the 2 volts to the base of the transistor. This will be the positive side of the 2 volts from the trigger winding. And this is the negative side of the trigger winding 2 volts. So the negative, here the positive, goes this way. It's the base. The negative goes this way. It's the emitter. Triggers the base like that, Closes the gate. Allows this negative here to touch here on the coil. And of course, this positive is already touching. Okay. All right. Was that too fast? Was I too fast there?
No, go ahead. We're good.
No.
We're right in line with you.
So that's basically an oscillator, you're just switching on and off the transistor with the magnet on the wheel.
So basically just that switching action is creating the oscillation.
Right, the trigger coil is creating the switch on the transistor, but you see that how the running battery is hooked up to the coil on the positive side already. Mm-hmm. And the negative side has got to go through the transistor to be connected.
So would you say the switching action of the transistor is like taking the place of a function generator, shaping the signal, pulsing it or whatnot?
The switching action is just going to turn it on and off, and that effect is what it takes to generate a radiant spike, is to turn the switch on and off. That's all you have to do.
And isn't that what a function generator does? Like in a square waveform, it's just turning it on and off at a certain frequency?
Well, a function generator has like capacitors in there to create square waves and keep the line up a little longer before it drops. And they have circuits to shape the signals the way you want them. This circuit is designed to shape the signal like a flyback signal, like a radiant flyback signal.
Oh, okay.
So the resistor in there.
Yeah, because there's no capacitors to actually keep the voltage up or do any shaping like that. There's no capacitors in this circuit, but there is a inductor and a switch, and that's all you need to create the flyback event, is to turn off the switch. Every time the switch is turned off, this event happens, no matter where the switch is or what it's hooked up to. And this is why, the old TVs used to blow out, the old tube TVs. they had transistor tubes in there, and when they would turn off the TV would blow up. Like,
Oh, the cathode ray tubes, yeah.
You know.
Okay, so
very
real quick,
common.
Mike, real quick, the resistor. I want to get to this part on the resistor before we get to the transistor. And I believe he said 830 ohms is where you started. Can you please explain why it's 830 ohms based on what the magnets are?
830 ohms?
Yeah.
On
the resistor going in before we get to the transistor.
Oh, okay. Yeah, that's just to limit the current on your trigger signal coming from the magnet right here. The 2 volts coming from that hitting here has some milliamps to it. Not a whole lot, but then again, keep in mind, as this wheel spins faster, that those milliamps go up. So having a potentiometer here, you can turn down the milliamps so that the strength of which the switch closes is a little weaker. So the more milliamps you give the transistor at the base with your voltage, your 2 volts, the stronger the contact will be. So that makes a difference in all these effects, you know. If you have a very weak contact and brief, as opposed to a very strong and firm one, all these things matter. Okay. But anyway,
I was wondering about the heat.
You could tap really fast and by not touching very strong, you know. So that's by limiting the current with these resistors right here, you know.
I was worried about the heat. So when I watched
that's 100
Bedini about it, it was the reason the resistor was so low is he wanted to reduce the heat because he wanted to keep it mostly potential when he had the magnet come over the coil and he put the rods in
I believe that those
rods.
resistors limit the duty cycle from being, you know, too long. They limit the current, so the less current going through, the longer the switch stays down.
Right, but the less heat that the circuit gets is the less amps.
Well, this is just a trigger signal, so it's not really handling much amps. This whole circuit here, where is it? Sorry, let me go back. Right here.
Okay.
This part of the circuit.
Let me just explain why. He explained when you take the neodymium magnet and you put it in there, it takes the core of the actual coil, and what it'll do is it'll heat it up because it puts too many eddy currents in it that cannot get out. That's why they use the welding rods in order to disperse the heat. Then they put the resistor in the circuit to make sure that you don't have overdue heat in the circuit with amps. So based on that, when it flows through to your transistor, it's now potential instead of an actual AC voltage. You're getting pure potential through it without the heat, without the amps.
Right. Well, that's the coil that handles the amps right there.
Right. It's going to matter when you go put it past the transistor into the diode before it gets to the battery. Because that's where it's going to make its special H wave.
Wait, what's an H wave?
It's basically like you see like a molehill or a sine wave on the top. Okay. Mm-hmm. And it looks like an N, except for the N part turns into an H part when you get a spike. So you basically have 90 volts that comes through the system, right? And then at the very top, it goes from 90 to 300 is the way Bedini described it. Therefore, you get a spike in the voltage at that point. And then the spikes, he keeps adding those up. And that's what's going into his battery to charge it so fast.
Right, but all the amps are going through any kind of amps are coming from the drive battery, and it's going into this coil alone.
Well, we know about just by.
The drive battery is isolated from the trigger, so this is just a low current, low voltage trigger signal. That's all the trigger winding is doing. But all the amps are going in here into the other coil, And yeah, if there's resistance, you got a bad battery or something, it will heat up this coil, the drive winding. And I don't know about this one, but it'll heat up this one, and it might, damage. I don't know. It might harm the transistor. I mean the diode.
Have you actually attempted to build one of these?
This circuit here, I've built over a dozen of them. They're not.
Is that what that video that you sent us?
No, that's a different one. That's based off the Newman's setup.
Okay, let me add a video to this so we can look at it. I just want to look at it with you.
Well, I feel that
I'm not sure which video.
I've probably said this 1,000 times.
So
Taking the degrees, not.
Here's what I'm going to do. I'm going to set this up for you. And he talks about why he does certain things. And you just tell us what's going on here. So,
Okay, that's a good idea.
Okay. So
And there's a belt going from here to here. It's more than enough that it can drop or go.
Yeah, we'll get past that part right here.
So one way to do this is if we want to use a PNP, we would put a PNP transistor. And a PNP is designated like this.
P stands for what? And N stands for what?
PNP.
No, I'm sorry. Yeah, that's a PNP transistor.
No, it's an NPN.
Positive, negative, positive.
Yeah, watch.
Okay.
Okay, but we don't want to use the PNP because
it's an NPN.
We want to be able to capture a different form of energy. We're not looking for the normal form of energy. We're looking for a different form of energy. We're looking for a form of energy that is basically currentless. We don't want any current. We want the current to build in here, but we want to shut this current off. We want this current to build a magnetic field, but we're going to shut it off right away. So, what we want to do is we want to use just a basic NPN transistor. And of course, in this loop, this is the ground.
You want to pause it for a second? I got something to say
absolutely.
here.
So,
Here we go.
Right
Go
where
ahead,
he is
Mike.
at the bottom there. You see the ground where they. Well, that's the battery negative also.
Okay. Yeah, I imagine all the grounds going to one, so it'd be technically one line.
Right. So the transistor is going to close and give you the negative. So on the top of that coil is where the positive is jumped already.
Right. And
he's going to switch the negative to energize that coil. But by switching the negative, I see he chose to switch the negative because it's negative energy. What other reason? It's behind the zero line energy. It's the negative zero, negative one, negative two, negative three, like metric. It's that.
This is the reason it gets a special effect. This is why I get excited about this motor. So let's watch a little more and tell me where to stop.
I mean, you could switch the positive or the negative. Yeah, but
we know that we want to connect the battery. And we'll just put that one to ground. These two grounds match. So just think of a line between them. Okay, the next thing that we want to do is we want this wheel. We're going to move these magnets. So if I move these magnets, we want, when the wheel moves, we want this magnet to be attracted to this iron. Now, as this magnet, which has a field around it, comes into this iron pole, it's building a field inside this coil of wire. And we're going to use that field to turn our transistor on. So very simply, we would just come like this with a resistor.
Way better than a reed or anything
And I'm
else.
telling you where to start. 680 ohms.
Oh,
I don't want you to
misread
put a
that.
47 ohm there. I don't
680,
want you to
that's
put a
even
10
lower.
ohm there. And I
That
don't want
sets
you to
your
put a 100
frequency,
ohm
your
there.
RPM.
I want you to start at 6.
Go ahead, Mike.
I mean, that 680 is going to set your oscillation rate, your frequency. If you get that to self-oscillate with a 680 ohm, keep in mind, you could make a Bedini Bifilar that's more than 150 feet long. You can. I did this with 5,000 or 1,500 turns of. I don't remember. It was 1,500 feet. Sorry, 1,500 feet. I did one coil with 1,500 feet of gauge 32 on the trigger. I'm sorry, no trigger. It was just 1,500 feet. That was solid state triggering. I didn't have a trigger winding.
Okay.
I did like 1,500 feet of like a gauge 30. What was I getting at here? Yeah, the more turns you have, the higher voltage spike you're going to see. So on that one, I was seeing like 1,200 volts or something.
Let's get to the reason why he was putting the transistor in there. It's kind of the reason I
From a
was
12
alluding
volt
to
pulse.
earlier in this.
680 ohms.
Sorry, resistor.
I want you to get as much wire as you can get on this bobbin that you're building the coil out of. I want you to get as much wire as you can. I want you to fill it. You don't have to count the turns because you're going to tune it. So it's not important. Then I want you to put a diode in here. And you notice these are all going to ground. That means this ground, this ground, this ground. And what this diode's going to do is it's going to clamp the transistor on the reverse spike.
That's what I thought it did. I couldn't figure
So
that
the
out.
symbol for the battery is this, plus and minus. And I want 12 volts here. So I want something like a motorcycle battery. I don't want little bitty batteries that are this big that you buy because they're $3.
Right.
Because you're not going to gain anything with a battery that's this size.
You want me to explain
It's
how
going
it
to give
clamps
you
the
1.5.
Absolutely. Go ahead.
Okay. Bring up the circuit that I have loaded there. The diode is there, yeah. This is positive now. Right.
So far we have the diode
So what
on
happens
the bottom.
here, what he says that diode, I'm sorry, this diode right
the diode
here.
on the bottom is just in a slightly different place, I was going to say, than where he had it.
No, it's
But
exactly
it does the same
place.
thing.
Same place.
It's right. Is what I'm saying.
Correct. It's the same thing. Reason why this diode is clamping the transistor on the reverse spike. How is it doing that? I'm going to show you. If you don't have that there, what happens is you got the plus here. This is not the reverse voltage. This is the forward voltage, plus and minus, right? From the battery. See it? Okay. But when this coil reverses polarity, it's going to go minus plus. Now this becomes minus and that becomes plus. And that's high voltage plus. And where's it going to go? It's going to go right through this diode, through the battery, the charge battery, and through
I think it stops at the charge battery.
no. It goes through the other battery. And this is the positive. No, so it can't do that. Maybe that's not the path. I'm trying to figure out how he. stop the flyback signal from triggering the transistor because you don't want that.
Well,
Otherwise
let's take a look, and then you could tell us, because I think he's going to tell you where the spike is. It's right after that.
This is your
diode.
positive spike right here. This is your negative. So maybe the negative is going. Yeah. So the negative spike can go this way, and it can go through the collector to the base, and it can go through this diode too. The negative.
I don't think
The negative
spike goes that way.
Negative. Negative. Yes, it does. Negative goes that way. Goes to here, to this
Not the
negative.
spike.
The negative spike right here. This negative spike.
Well,
but it has to meet the positive somehow, right? Which is right here. Going this way through this battery. And it meets itself right here. Yep, he's right.
all right.
Bedini is doing it correctly. He clamped the so the negative was able to go through there.
You can't go through the diode.
The positive can't go through that diode. The negative.
So,
can.
real quick, clamping.
I'm sorry, you're
the,
right. You're right,
trans-
Nathan. You're right. My God, you're right.
The spike is after the diode, so that
The positive.
that
So,
No.
real quick,
can go
direction
through this
only.
diode, Nathan. The negative can go through this diode. That
no,
way.
I understand that diode down there. It's not the one I'm
Positive can
talking
go
about.
that way.
No. But the other diode you're going reverse on is by the plus in the middle of the whole thing.
Well, if this is your plus flyback here,
Right. So the diode right to the right of that is the
yeah,
one
it'll
you
hit
said
this
it went
battery, and
reverse
the
through.
negative will hit this battery. Yeah, you'd think it would stop
just-
there.
It can't go that way.
The negative flyback does.
Yep, but it can't go through the diode.
No, but it hits the battery. It stops right there.
Right. It's just
But it should stop right there, but it doesn't. He's obviously it doesn't because he's put this diode here to prevent.
he's got a low and a high on this circuit. Okay. He has a very low trigger and he has a high side to it. So the high side will stop between the diode and battery at the spike. So let's just watch it and then you could tell me again, okay?
Yeah, if you can figure out
You're
how this
not going to be
diode
able to run the machine long enough to
stopping
see
the
anything.
flyback from triggering it.
So I want a big battery. I want a garden tractor battery. I can't make this any plainer. I want a big battery. I want at least 13 amp hours. It's mandatory. And the charge battery, I want at least 13 amp hours. So, next step.
Yeah, just to clarify, you want both batteries to be 13 amp
I
hours.
want both batteries. Both.
Right.
Now, the reason that I want both batteries at 13 amp hours is so you have time for the machine to see how the machine works. And you don't have to worry about, well, geez, in 20 minutes this battery ran down and I didn't get anything. That's right, you're not going to get anything. You're not giving nature long enough time to do anything. Nature's not going to come right in and charge your battery over there instantly because she doesn't work that way. She works very slow. So anyway, back to this. We want this to come in and charge this iron pole. And we want enough mass weight on this wheel. We don't want a roller skate wheel. We want something that's got a little bit of mass to it. Now, I know that a lot of people out there have made roller skate motors, but it's not buying you anything. You're not getting the advantage of the mass in this wheel. So, we give it a start.
You're talking inertia, really.
Inertia,
Right,
but mass weight.
right.
In other words, we want something that has a little bit of mass to it. Say, we don't want, say, 4 ounces. We want more like a pound. All right? So, because we want the thing so that when you give it a spin, it can carry itself around until you can figure out and get this trigger circuit operating to optimal, which means that it's going to operate this bell curve. And we want to be running somewhere here in the curve.
What are the axes on that curve? What are the
That would be resonance.
and what are the parameters on that curve? I mean, is that current,
Well,
current against voltage?
Yes,
or-
that would be where the motor's running the fastest with the least amount of current.
Okay.
So we want to be in the bell curve.
You get there with the
We don't,
potentiometer.
we don't want to be running the motor down here. We don't want this flattened off. I don't.
I'm still confused by
Well, I'm going to,
okay.
look, this motor runs at what we call into a resonant point,
So that's
where it's the
RPM.
fastest it can go.
Okay.
This is the fastest RPM it can go with the least amount of current. Okay? So we want to be running somewhere in here. We don't want to be running here, and we
When he
don't
says
want to be
least
running
amount of
here.
current.
If we're running here, you're going to burn the motor up. It's going to smoke the transistor. It's going to get hot.
That resistor.
We don't want anything
680
hot.
ohms. Limit the current.
So we don't want the coil hot.
Trigger.
We don't want the transistor hot. We want this to run.
So, Mike, that's the
Basically,
low
however
side, right?
much current you give your trigger signal is the same current that the collector emitter is going to let pass through on the other side of your source, whatever source you're feeding the emitter gate junction. If it's a 12-volt battery source, as in the Bedini circuit, that junction is going to have 12 volts flowing through it with whatever milliamps that you give the base from your trigger signal. So by giving a resistor of 680 ohms there, you limit the milliamps down to make a very, not only a very light tap, but a quick one with very short duty cycle. And like you said, as very minimal current as possible.
Yeah, so we're taking out the amps and basically making it potential.
Yes, exactly. Right.
That's what
exactly
we're looking
right.
for here.
That's
It's
exactly
a trick
right,
of the
Nathan.
whole
Best
circuit
way
to
to
get
say
the spike.
Going back to that diode, it's a low voltage diode that we were going over before. That's not a flyback diode. That's just, I figured out why that's there. That's to make the signal hitting the trigger winding with the magnet. It's AC, but you got to make it DC, right? So you put the diode there and you clamp it into DC. That's what he
It
means.
won't
by
make
clamp.
it into DC with one diode.
Yeah, one diode.
No,
Makes it a DC pulse.
Nope.
DC half
that's
wave.
not the way it works. You got to use a full bridge rectifier if you want to get to a DC signal out of potential.
Yeah, but the magnet's only passing over. It's not going to need a full bridge.
Oh, it is. But he's not going to try to get to DC at all. That's the whole point of this. So
No, he wants 2 volts DC hitting the base. Now, when the north field of the magnet goes over the trigger winding, yeah, it's going to create alternating current.
he's looking for a potential spike of 300.
Well, it's a low
volts.
voltage diode. It's not a high voltage diode. It's a
understand
1N4001, which is a 12 volt diode. So it's got nothing to do with the high voltage, that diode.
Okay, well
something to do with low
let's see what he says, because
He doesn't go into it. That's the whole thing. He never goes into it that much, that particular diode, because it's a low voltage. He called it a clamp. I think that's a DC clamp. That's what they term it. It's to guarantee yourself more of a DC signal, less of an AC. I think.
Okay,
That's
I
what
think I've watched the video. He's got it in here, so let's check it out.
On that diode, I've never seen
Right
it.
here in this bell curve, which is max speed, least amount of current. And you can tell by tuning this resistor down here. If you move down and speed up, then 680 ohms was too much. If you move up and the current goes down and the motor speeds up, then that means that's the least amount. That means that the pulse to this motor is very sharp and very quick. And that's where we want to be.
Right.
We want to be at the very sharpest pulse we can get, the sharpest transient.
That means like no duty cycle.
So, the next thing is now we have our basic circuit. So what we have here is something that's waiting to be triggered. It's like a magneto. The magnet has to come in here, has to charge the iron. There has to be a discharge take place, transistor turns on. rotor gets kicked away. Okay, now a lot of people ask, well, what are the degrees of that? Well, this can vary on how many poles that you have. But a good rule of thumb is just take this point and watch the motor once it's tuned, and you'll find out that it's probably coming in, charging the iron, leaving, and firing right here. So it's after. It's after top dead center. And this can be anywhere from 2 degrees all the way to 23 degrees. So if you just look at it, as if you have a bunch of magnets, around here, you take these and center them all. It's always going to be after the fact. So if the motor's turning this way, it's going to be over here. 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 And so on. All the way around. Well, what are you going to do if you have 8 magnets and this is, say, 15 degrees? See, we're only taking the degrees, not the entire circumference of the wheel. We're only taking the degrees between the center of this magnet and where it fires.
So really during the work cycle.
Right.
Yeah.
Right.
So which is where the confusion arose.
This is where the confusion arose.
Right.
I wanted to clarify that. These are the degrees you're looking for. Okay, and when you're in resonance, this will be at the furthest point. So you may be 18 degrees, you may be 23 degrees, depending on how big this wheel is. Because wheel size also makes a difference. There's no true set timing for this machine. It times itself, and the reason that it times itself is it's self-servoing to the load. So, we have the motor running, we have a 2-pole motor running. It's running now with this circuit. So, this battery is indicated by this battery here. I'm going to put another battery down here.
Do not put another battery?
No, put another battery.
Okay.
Okay, so now, what we want to do is we want this machine to run, and we want this machine to convert energy for us to a different form of energy, because you're not going to get this battery at 12 volts to charge this battery at 12 volts. So you have to convert the energy to do it. So what we do is we just put a diode here. And we put it to the positive pole. And we take the negative pole and come back up here to the positive. See how that works?
Yeah.
So that's the second battery, right?
That's the second battery.
Right.
Okay, so what's actually happening here is, if you really analyze the whole situation, is you're using a little bitty signal to build a 24 volt pulse, because you have two 12 volt batteries.
Right.
Okay? So, what we're looking for in this pulse, and sorry about the motor, what we're looking for in this pulse is something that sort of looks like this. And if the windings are correct and the resistor is correct, this should be at about 300 volts.
So this is the H wave?
Yes. Not all will look like H wave because no one knows exactly what they're going to use for a core and what they're going to use for magnet. Now I'm going to make this one statement here. Do not use neo magnets. Use ferrite magnets. I've probably said this 1,000 times, and now I'm telling you, do not use the neo magnets because you're going to saturate this. This is going to be at the wrong distance between here and here, and you're going to fail. And that's all there is to it. You're just going to fail. What you want is a ferrite magnet here, a number 8 ferrite magnet. So I'm clarifying this for you. That's what I want. I want a ferrite magnet. I don't want a neo magnet. So I'm looking at voltages between 90 and 300 volts. Now, for all you interested in, well, I can't measure anything here with a meter. Well, why can't you? Why? Because you're only dealing with this little spike right here. It's not very big at all, is it? But what it is a hammer blow to this battery.
To which battery? Sorry, I missed it.
To the second battery down here. This causes a sharp transient to end up on this battery. Because this battery, battery A, this is A, and this is B. Battery A just supplies a trigger current for this device. Because what we want to do is we want to trigger the energy out of the field that builds in this coil. And we want to send that back to this battery. So actually what we want to send back to that battery is all these little spikes that actually look like this. Because that's the only thing you're going to see over the battery. And you're probably not going to see them at all because the impedance is so low here that the chemical is going to absorb it. Now, I'm not looking for current here. And one way to test this is put a 1 ohm resistor, take this battery out and just put a 1 ohm resistor here in between these 2 points. And if you are developing current, your machine is running incorrectly. All right.
Have you got?
All right, guys, let's take a look at this. Let's bring everybody back in.
Notions as to why it would be producing current?
All right,
Why?
pause it again.
Pause it for a second. You see what
All
I said?
right, so-
If you're developing current, you're developing heat.
And
So
the
he's
motor
right,
fails.
Right, that's where your heat comes from. You're just, you need to add some more resistance to the base and weaken your pulse, like make it more quick and
So
stop the current from flowing. Get rid of your duty cycle, get rid of as much of the duty cycle as you can.
I don't know that you're getting rid of any duty cycle here. It's pretty much set by the spin of the magnets. What I'm looking at
Well,
is,
no, because the resistance of the resistor to the base will limit the current and help keep the duty cycle low, even though the magnet's spinning slowly over.
right, but it's a set parameter.
Well, yeah.
Once he puts a
right.
resistor in and he has the speed, you're done. It's going to be a constant. What I'm looking at.
It's strange because that speed is not. It only performs constant on a healthy battery, healthy load.
Okay. Here's what I'm getting at. We were looking before at your circuit, and it's a little bit different than his. So he's got, right after the transistor, we have the
No, this
diode.
is the same circuit, the same.
A little bit, but he has the battery in there wired, the positive straight down to the negative.
The top
on
battery
that
is
side.
the run battery.
Yeah, the second battery, the one on the bottom right.
That's the charge battery.
Yes. So that's a
Same
little
thing.
different than the one you showed us.
No, it's the
Because
same
you were
thing.
going all the way around with it, and it's just a, you know what I mean?
Only thing different, I don't see a
Because
diode on the base. He doesn't have the diode hitting the base there.
His
anymore.
primary battery goes to ground, and you had the circuit you had goes from instead of the ground, it goes to the second battery. So it's a little bit different on that end. What I'm getting at here.
Yeah, this is one of his other circuits, right?
Okay, so what I'm getting at here is right after the transistor, after the diode is where you're getting your spike at. It's exactly where he says he found it. And it's between 90 and what do you say, 300 volts? So you're getting 210 volts right there on a spike of pure potential. And he says if you have a resistor between the battery terminals right here, or take out the battery terminals, put a resistor in here, and it blows, you have too much heat in the circuit. So the positive that comes down from after the core itself on the transformer there, or the coil, I should say.
The bottom diode is the flyback diode.
Right. It's just there. He's just making a point on it that if you put it across there shouldn't be any heat. So what he's saying is he's taking that voltage and put it into the negative side, and he's putting it in the positive side. Both sides have no heat.
Yeah. I mean, I'm trying to remember which circuit this is. It looks like the one where he uses the ground.
So I guess the biggest question I have in this whole circuit.
He has one where he channels the negative flyback signal through. This is this one, I think. He channels the negative flyback signal to meet the positive flyback signal through both batteries. He calls it forced charge. This is the forced charge circuit.
There we go.
Right? Is that right? Is that the one he's looking at here? Yeah. Okay. So that's the one, right?
We're looking at potential spikes. That's
right.
The only reason I look at these things in these motors, guys, I love spikes.
I've never replicated
potential.
This one, so,
I love things without current because they act so much different than a traditional, so many volts, so many amps circuit. It totally different circuit will completely react differently. So the voltage spike is
what the
charging it
force charge
faster.
is doing.
It's charging the battery faster.
No, not only that, it's, how do I say this? It's charging, it's using one of the battery. I think it's using the run battery to channel the negative side of the charge battery to meet the negative flyback on the flyback coil. Of course, the charge battery's positive side is already connected to the flyback diode, and that is connected to the positive flyback side of the coil when the coil flies back. But the negative side of that coil, the flyback negative, is going to go through the run battery, its plus terminal, and its minus terminal to meet the negative terminal of the charge battery. I hope you followed that. That's the force charge. That's how you force charge the primary because in the other circuit, the primary battery is the running battery. The secondary battery is the charging battery.
Yes.
So in the other circuit, the only battery that's getting charged is the secondary battery.
Right.
In the force charge circuit, both batteries are getting charged.
Well, then
the primary and the secondary. And the way he's doing it is he's sending the negative flyback through the primary to meet the negative terminal of the charge battery. Of course, the positive flyback is already connected to the charge battery positive through the high voltage diode. So that's how that force charge is getting the negative flyback side to go across the run battery to meet the negative terminal of the charge battery, because the negative flyback has to meet the negative terminal of the charge battery for it to charge the charge battery, and the positive flyback has to meet the positive terminal of the charge battery for it to charge the charge battery. So to get the negative flyback signal to meet the negative terminal of the charge battery, he is sending it through the run battery. I hope that got there. Yeah. Yes, no, maybe.
Oh, all of his grounds go to the same ground.
The negative
So-
flyback is high voltage. The battery's not going to stop it.
But it's not
And so
necessarily
he's
high
putting one
voltage.
battery in series with the negative flyback signal.
No, it's the flyback isn't high voltage.
What's
not
charging the primary is only negative flyback flowing through it. It's not getting any positive flyback, but it's channeling the negative flyback through it to get to the negative terminal of the charged battery. That's
So-
how I figured it out.
Is the negative charging
Because
the
you can
positive
flow a
to
negative
amplify-
signal through a battery, the
Hey,
two
Mike,
terminals of a battery,
is-
and run it up, run
Hold
it
on.
up.
Is the negative channeling back through the circuit in order to get the spike along with the
He's not
positive?
using the negative flyback in the process of charging the run battery. He's not using it to create the spike. He's just using it. He's using the spike that was created, the negative side of that spike, to go through the run battery to get to the charge battery's negative terminal. And in the process of going through the run battery, it's charging it up. See, the negative signal alone is going through the two terminals of the run battery. It's hard to imagine, but yes, you could do that. It's still a wire in there. That battery is still got continuity of some kind.
Okay.
So that
So
either a
Listen.
positive can go through it alone, or a negative can go through the battery alone on the
look-
way to its positive.
let
To
me
get
just
the
say,
flow, you got to go to the, you got to have its inverse on the other end. If you
let
put
me
the
just-
battery in the line of that, it's gonna, the flow is gonna go through the battery.
come on now, Mike. Let me get a word in.
All right, go ahead.
Okay, listen. There is no positive and negative in potential. Okay, it's why he gets a spike. No matter how it runs through here, it runs like static electricity through his circuit, and it spikes.
Right.
There is no
Right, but you
positive and
can't
negative
collect that
to
spike.
potential.
Right.
He's directly putting potential in both sides of the charged battery.
Right. You have to collect that spike. You have to collect it by collecting both poles of the spike, the negative
with
and the positive.
So, but without the heat, he's getting no ability for that stuff to push back on him. See, the amps will push back on everything. That's when you go from potential to something that's semi-close to where you can convert it. He doesn't have the amp, so he gets the potential full on both. That's why
It's
he
all
puts a
potential. This is
resistor
a
in there.
potential device. It's not an amp device, but yeah, it sure looks like an amp device with a wheel spins.
It can't be an amp device. I can tell you that right now. It
It's
won't
not.
work.
It's not. It's milliamp device. It's a milliamp device.
Right. That's why it's potential. This is why patent offices, by the way, have so much trouble with this entire thing, is because they don't know the difference between potential and AC and DC. They still think potential's AC, and they can't tell the
What?
difference. So they'll never
Potential is
recognize in a
voltage. Doesn't
circuit
matter what form
what
it's in.
anything does. That's what I'm getting at here. It's kind of tricky the way this guy does it, but it's exactly what's going on. That's why I like this guy's circuit.
So by potential, you mean electrostatic potential, like the voltage alone, not
Yeah.
no current.
It's indiscriminate. It's not positive. It's not negative. It's just a potential amount of energy that hasn't been converted yet to an AC or DC form, which we're used to seeing, but it's pure
Still
potential.
there. Yeah, it's still there. The energy, it's still there, able to be used and tapped into.
Right, and any potential device is gonna pick up on that on potential. A battery is a potential device.
But that's what he's getting at in the motor itself as it turns and the magnets that he's using. So remember, he said no neodymiums, and then he also would tell you that you want the core of this thing to be the welding rods, the real thin copper welding rods that go in the center so it disperses heat. He doesn't want any heat in the system, and he tells you in the beginning he automatically shuts it off is what he wants. He wants it on, the whole thing to charge so we can get the charge out of it and automatically shut the amps off.
So I didn't really understand the difference between using the neodymiums and the ferrite. Was it?
It produces heat in the neodymium.
Okay, here's the difference. The difference is the ferrite magnet is going to send more voltage to the trigger winding and less current. And the neo is going to send more current to the trigger winding and less voltage.
And the current's
which will
what's
do
producing
what?
the heat.
Which will do what? In turn, it'll tell your transistor to allow more current flow.
Mm.
You know, because it reads the current. Once it hears, here's 2 volts, it turns on. But after that, the transistor is reading current. How much current is behind that 2 volts? And from there, the transistor can create a duty cycle. So when you're using a neomagnet that creates more current, it's stronger. So you're going to have a longer duty cycle. You're going to have a harder time. You're going to have to add resistance to the base to get around that. But you can it'll still work.
It's going to kill your transistors. What it's going to do.
If you don't add
more
resistance to
about
the base,
balancing
yes.
the system.
If you start adding amps to your thing with neodymium magnets, say goodbye to your transistor in the first 3 seconds. We're smoking. It's
And
over.
another thing is, if you do add resistance to the base and save your transistor by using neos, the neos are still going to fill up the coil and create more cogging because the amps.
Right. So you get a double S sandwich.
So you're slowing down the wheel. You're
Yeah.
slowing down the wheel because the coil's filling up with magnetic field faster from the neos, whereas ceramics have a weaker field. So you don't really slow down the wheel. It's just to trigger. It's not to.
It's more than that, though, because he's using
The magnet
opposite
on
side
the
of
wheel
it.
is not there to create power. It's there
Yeah,
to trigger.
he's using the other side of it to charge the negative, though. So he can't have amps there either.
Charge the negative. That's
right there. You see
that's
it.
the whole thing. That negative that you're talking about is coming from the battery, not the magnet on the wheel.
No, I understand. Look, it's coming right off the top of the core on the positive. I see the plus. I see it going right down to the negative of the battery on the secondary battery on the bottom.
Yeah, because where the plus is now, it becomes a minus when it flies back.
You're misunderstanding what I'm getting at here. There can't be current in that either, because if he puts the resistor in there and takes it off the terminals of the battery and puts in a resistor, it can't have heat. Exactly what he described. Okay. Which means that he's pulling potential from the other side as well, not just the trigger. He's not charging it conventionally at all. This is not flowing one side, flow out the other. This is flowing both sides.
Right.
That's why he says 24 volts, not 12 volts flowing in a circuit. This is what he means.
The opposite of what they teach you in school of how to build a circuit.
Exactly. That's why it's special.
And
that's
this is something that
people don't figure it out.
Yeah, and this is because they just listen to the mainstream and they don't think outside the box or think, like, oh, maybe there may be more that we're missing. Like Gerald, he said his coil is utilizing at least 7 different unconventional methods that would go against conventional teachings. Like putting capacitors too close together where they have they feed off each other, right?
So Gerald, by the way, just put out a video, okay? And he's using a drawed Morin device in order to charge that actual what do you have on there? Lights on there. One time he also had a battery that stayed steady at the charge.
Oh yeah, I saw that.
It's just that little pump motor. So just understand this. He hasn't rectified it. So it is actually potential going in there, and he charged it overnight, and he's getting it to stay steady. It's the trick of using potential. So when you see his device, I guarantee you he has that going on in his circuit.
Interesting.
It's far and away one of the most interesting things about this whole device.
Yeah, this is all really cool.
Speaking of bifilers, how come nobody ever tried using a bifilar as a stator pickup coil? That's amazing to me. Nobody's tried that yet.
I don't know.
Well, that's basically what the rodent coil is, the PoE. It's a bifilar.
A typical 3-phase generator has magnets on a rotor. You spin the magnets over a coil.
Mm-hmm.
Why not a bifilar coil?
I think that's what the First Stop Energies was researching before they kind of went quiet. You see like videos of them spinning giant.
Oh, you have G,
rotaries.
huh? Ah.
Hey, Gerald, I'm on your case, buddy. I know what you got going on there. Trust me.
Oh, cool.
I have to mess with Gerald a little bit because every time, man, he always makes me wait a little bit. He gave me a little bonus this time by showing me the battery charge, but I'll tell you right now, he makes me wait. I want to see that his coil and even explain it, man. So it's
one of
just
these
all
days
good.
he's gonna give a presentation. He's just gonna open up a portal to another dimension.
Oh my gosh.
Well, you know, I'm thinking at the very least a bifilar stator coil will be less cogging, if not more cogging. But if that's the case, you'll get a lot more amps out of it.
He's going to make all those math people go absolutely insane pulling their hair out. Trust me. When they find out everything he's using here, talk about all the letters coming into your algebra equations and your physics stuff. Oh my God. You're gonna triangle here. We're going to go over here. You know what I mean? That's over here.
Academics saying they got to relearn everything.
Yeah. Hey, Ben, why don't you handle a couple questions for us, man? Some stuff that's going on in the chat.
Yeah. My chat
really
crashed, so I had to
restart.
Chat
crashed?
Yeah, my stream crashed.
On the stream?
No, I restarted the stream, but there's nobody watching my stream right now.
I could talk a little bit about the circuit I'm working on. It's based off the Bedini concept.
Okay.
And the differences between how he's switching and how I'm switching, and why I'm switching differently. And it's to accomplish one of his goals, which is to dump the radiant as fast as possible. Let's put it that way.
Okay, you got a video on that, Mike?
Yeah.
Okay, shoot it up here and I'll put it up.
All right, I'll do that.
Nice.
I'll go ahead and remove this one off of there for you guys. Man, it's an entertaining conversation, isn't it?
This circuit is the same Bedini concept, modified. It's Bedini modified. I think the best name for it, which I thought of it as today, I'm going to call it the Bedini bounce.
The Bedini bounce. I like that. Yeah, John Bedini's an interesting fella, isn't he?
Yeah.
The Bedini bounce.
And I think starting to understand some of what he's trying to explain by having you guys explain it in more simpler terms.
Okay, Mike, that's what we got right here.
Yeah.
One.
Let me go back.
You want to repeat this process over and over and over. But what you really want to do is you want to go as fast as you can.
So, and there's the circuit. Let's see here.
You know, I saw you guys doing this on Sunday, I think it was. You're talking about this.
Sunday. Okay. This is a double pole, double throw relay. I'm using it to energize two different coils.
Okay.
One to the other, back and forth. Energize one, de-energize that one, energize the other, de-energize that one, energize the other. So none of these coils are energized at the same time.
Okay.
So, and you can see that in motion here. Pins 3 and 4. Pay attention to that. The arms. And so this is the mechanism. You can do this with transistors, but this is the way you would set up transistors to do it. With transistors, you would do it the way a double pole, double throw does it. And the circuit is to the left there with the two batteries. I wonder if I could zoom in. Oh, you know what really matters here is this. Right there. You see how it's switching both poles of the battery?
Yes.
Okay, so each battery What this circuit is doing, in the Bedini system, you have a run battery and a charge battery. And they stay that way until the run battery is empty and the charge battery is full.
Okay.
This circuit, and in the Bedini system, he switches one pole, the negative, not the negative and the positive. In this circuit, both batteries are the run batteries and both batteries are the charge batteries. During one event of the switching of the circuit, one of the batteries is the run battery and the other battery is the charge battery. It receives the flyback. And the next event, it switches over to the other battery and charges that other coil. There's two coils now. So that's what's the difference. There's two coils here, two drive coils. There's no, the trigger is the double pole, double throw relay. You trigger that. There's no trigger winding.
This is basically like the old circuit, only way more advanced.
Yes. Yes, this is what everybody's looking for, man. Everybody's looking for a way to stop having to swap the batteries and automate it. This may be a way to automate it so you don't have to swap the batteries. Okay. Otherwise, the run battery is going to get drained, and you got to move it to the charge side and move the charge battery over to the run side and keep your system going. And that's a manual process. So if you see the diodes on the circuit with the two batteries, those are high voltage 1N4007 diodes, and they're both pointing at the positive terminal of each of the two batteries, right? And you can trace it to the coil. That side that it's connected of that coil is on top of the other battery. Do you see that?
Okay.
You do, right?
Yes, I see the double. Yeah.
Mm-hmm.
And I see the switching.
So the coil that's on top, let's stay with the battery on the right. The coil that's on top of the battery on the right is going to receive charge from the battery on the right when the two switches close. It will charge. And when the two switches open, the coil on top of that same battery will fly back into the battery on the left.
Okay. So let me ask you,
process continues.
What's driving the original voltage?
A 12 volt, those two batteries.
So there's no wheel in this, there's no magnets, none of that.
The wheel is to your top right there. You could put a wheel and you can put those two coils on top of those two batteries for 90 degrees apart on that wheel.
So that's the driving. That's what I'm getting at.
Well, you could drive a wheel like that, with this circuit.
No. What I'm asking is the wheel itself making the energy?
No.
Or is it just battery going to one to the other?
The batteries have the energy. So the batteries, one of the batteries.
Oh, so you can use this to drive something like a rotary?
Yes. This is a Bedini.
This doesn't make sense to what Bedini did, though. This looks just like putting battery one to the other and leveling them out. It doesn't.
Well, I need you to pay attention to the coil. You see where it says positive and negative, and it's red right now, the left side?
No, I see it. What I'm asking is, where's the extra energy coming from? Where's the drive coil?
Battery. The battery beneath the coil is giving it.
You're telling me you can connect two batteries and charge both the full potential without anything else?
One at a time.
From the other one. Where's the amplifier?
Gerald says he has a theory.
One more time.
No, there's no
amplifier. The coil sitting
amplifier.
above the battery is getting charge from the battery below it.
Okay.
Not the other battery. That coil.
Gerald says he has a theory.
Is the one getting the charge from the battery below it. The same thing for the other battery. That coil is getting charge from the battery below it. No other charge is coming to that coil from any other place other than the battery below it.
Okay.
Let's establish that.
You're going to have to explain this to me.
No,
Benny, go ahead.
The coil above the battery only receives charge from the battery below it. No other place.
I was just saying that Gerald commented in and he said he had a theory.
The battery does not receive flyback charge from the coil above it. It receives flyback charge from the coil above the other battery.
So hold on. Where is the amplifier in this circuit?
The amplifier?
you have to have something that gives it more energy than what you're putting out from one battery in order for it to be able to charge one to the other, in order to get
This is an
both batteries up
efficiency
full.
design, you know. I mean, I'm not trying to, you know, do over unity. This is efficiency, you know. So I don't know if it's over unity or not, but I do know it's highly efficient because the
It's
flyback
inspired
is
by
being
Bedini's
received
designs.
to the other battery, back and forth. So the charge to the
Right.
coil
So
above
each
it,
battery is
from
receiving
the battery
negative.
below it, the charge is removed from the coil above the battery, and that coil flies back into the other battery.
Okay, let me
Not the battery below it, the other
let
battery.
me just say, how is the coil built?
It's just the same as the Bedini coil, the drive coil.
So are you driving amps out and volts up, or what are you doing?
I'm just collecting the flyback, the reverse polarity flyback, into just like Bedini does it, into the other battery. That's how he charges the charge battery, with reverse polarity flyback. So the coil, you charge the coil with plus and minus, and when you remove that charge, the polarity flips on that coil. If you have your diode arranged correctly, you can collect it.
So in order to collect it
flyback
from the
trick.
negative on the, in order to collect it from the negative energy on the positive,
It's
which is
important.
really
It's
unconventional,
important to look
is
at
it
the
have
top.
to happen fast?
It does happen fast. As soon as you remove the
Yeah.
the charge from the coil and
Like
the coil collapses, it reverses polarity as soon as it collapses.
Okay,
Like, yeah, he
let's
say-
And that's
step
when the
back one
spike
second.
comes
like a
in,
hammer.
after the collapse.
We're missing
Yeah, he
something
says like a
big here,
hammer.
guys. We're missing something big. And I don't think either one of you are hearing me when I'm saying it. In order for this to work, there has to be a spike somewhere in the energy. Now,
Spike
a
is in green.
a standard flyback takes a magnetic field, wraps it around the core. That will create a pulse in that core. That core now goes into the wiring around it and creates energy inside the secondary winding, okay, or the winding around the core. That then is the energy difference. It will go high volts, low amp. That's why when I ask you
That's a
how
step-up
the
transformer. or
coils
whatever.
are built, it steps up the voltage.
That's not what
why
this
it
is. This is
removes
not
the amps.
This is not a
That's what-
transformer. This is just a coil. It's just one coil. You energize the coil.
Then
plus
it
and
won't
minus.
work. If the way you're describing it, this is no
This is
different.
the way
than
the Bedini circuit operates.
you
It's a
could
coil.
take
It's not a transformer. It
if
has
I
a core,
wanted
yeah.
to level two batteries, I could do it very easily. This right here is a circuit that's switching on and off, and there's got to be a reason for that.
It's the reason you switch off is to collapse the field and generate a radiant spike.
There we go. Now we get to it. Radiant spike is the amount I'm looking for.
That's the
our
purpose
spike.
of this switching circuit.
Come
to
on, Mike,
generate
that's
radiant
it.
spike.
So
Okay,
that's the
that's it.
amplification
It's
right
the
there.
same
We
thing
found
as
it.
the Bedini
There you
circuit. It's
go.
doing the same thing as the Bedini. Nothing different.
Oh,
Only difference here is the.
Mike, I'm pulling your teeth here, buddy. Come on.
I'm trying to explain that difference, but I'm trying to explain the difference. So
I know you're
it's
trying to
still
explain
it's
different,
still a
but-
Yeah,
radiant
no.
spike generator. Okay, it's still
We're
a
all doing the best we
generator of
can.
radiant spikes, right? But the way it's bouncing the spike back and forth to each battery.
Right, but it's because you're
That's the
putting in
confusing
there,
part.
You're creating potential in the circuit where there was none before. Instead of it going a DC to DC, you're actually creating a spike because of the way you built your coil.
Right, yeah. I'm not going DC to DC here, not at all. If that's
No,
what
that's-
you think, yeah, no.
But just understand this: if you do not explain the spike, people will think that you're taking one battery and connect it to the other. Even if a circuit says something different, that's how people understand it.
Well, that's why I
if
say
you
the
don't
word
explain the
flyback,
spike.
because that suggests the radiant flyback is the spike. It is the radiant. The flyback is the radiant spike. It's just another word.
Okay, well,
for it.
just remember you can't assume. You got
But
to tell
everybody
people
knows that, right?
Yeah, nobody.
So it's the flyback is the radiant spike. It's the radiant spike Bedini's talking about. So, and I'm calling this a flyback loop. I guess I'm just using another word for radiant spike.
Man,
I'm
we're
not
all good
using
with
the
that
word
as long as you tell us what the conversion is. We're absolutely perfect with that.
The battery is doing the conversion by collecting the radiant spike and converting it for you.
So your potential on potential when you're going back and forth in the switching, so you're putting a lot more in volts instead of amps. Now, let me ask you, okay? When you start pulsing potential inside the battery, are you knocking off any of the garbage that builds up on the poles inside the battery? Are you creating an ultrasonic pulse inside there? Is what I'm asking.
The flyback, the radiant spike, yeah, I mean, it will knock off, it creates that shock wave.
Does it mess with the chemicals in the battery at all? Does it play with the acid in there?
I've used it on new batteries. I've used it on damaged batteries. I've seen damaged batteries at least show some sign of recovery, whereas any other charger would do absolutely nothing.
So I got a comment here
on the healthy batteries. I've never seen a healthy battery, go bad or nothing. But I've never really, fully. I've never run the spike over a healthy battery more than, let's say, a couple charges.
Gotcha. Okay, Mike.
So
let's come off the screen. Let's let Benny take a few questions from the people there, given all the comments online, and see what they say real quick.
Yeah, we got a lot of great comments here, Mike.
I'm gonna remove everything real quick along with us.
So first of all, we have Dead Fish Cheese Spread. Kudos to the name. He says Bedini uses AA's or 9-volt, I think. And I believe in the video we watched, he suggested a 13 amp battery. Is there any other circuits that he would use a smaller battery setup like that? All right, we have a comment from Terran Visitor. It is the radiant spike. However, when the charge battery has ions in motion, you are then swapping it to supply, which is against Bedini/Bearden's recommendations. So that's interesting. I don't exactly know what he means by Bearden's recommendations. I'm not too familiar with Bearden's work, to be honest. We have Terran Earthling. He says, if there is only one negative spike or positive spike to a battery, would create a triode discharge, cavitation evo between the battery plates. So that's going to create plasmoids, he says. That's an interesting theory. Plasmoids, as you know, are the root of atomic energy, free energy. A lot of free energy devices are supposedly, or we think, are utilizing plasmoids or bubble cavitation in some way. We know that Stan Meyer's electrolysis process was resonating the load with a conductor as well as ionizing the gas that's going into the chamber. And what that does is precondition the chamber for bubble cavitation. And plasmoids have the ability to absorb protium from the surrounding environment. And when they discharge, they can release an enormous amount of energy. I think up to like 1 kilowatt of power when they form in clusters, which are wheels within wheels. Dead
hey,
fish
Ben,
cheese
we
spread.
Got we got Faraday on here. He wants
nice.
to get in here, but I need his email in order to get the link to him for the chat here.
Oh, do I have it? I might have it.
If you have it, send him the link, please, so that he can get in on this.
I have a couple of people's. If not, you can email me at beneficencetv@gmail.com. Yeah, let me close this up real quick and we're gonna look for that. All right.
Sorry about this, guys. Just trying to figure it out how to get him on here so he can have a conversation with us.
I'm not seeing his email. Maybe he can email me. I put my email in the chat. It's beneficencetv@gmail.com. I'm still looking.
I put mine in there as well in case you wanted to go with that one.
Yeah, like but I'm still looking because I know I have a couple of people's on the chain.
Says development. I don't have it.
Exotic propulsions. Terran Earthling, Jeremy L. Tim Ventura, Charlie C. Yeah, I don't see it on this chain either, unless it's one of these that I don't recognize. He's gonna have to email us.
Yeah, I don't have it either. So
no, it's fine. Yeah, he could just email us and we'll send him the link.
Yeah, we'll just let you know when we get the email in and we'll put them on.
Yeah.
So let's go back to this, Mike. I'll put it back up there for us and add you back in. Okay.
So going back to what someone said about sending the radiant back to the source, that's the whole thing. In this system, one of the batteries is source for one coil, and that coil's flyback is not going back to that same battery. It's going to the other battery. And at that time that it goes to the other battery, that other battery is not a source for anything.
Okay.
You can see that in the switching if you watch closely. It's animated and it's in red. So the red indicates charge from the battery. Green is the flyback. Notice the plus and minus on the coil, how they change, and follow the diode direction. And you could see that when one battery is charging that coil, it's only acting as the source for one coil. It's not being charged at the time that it's giving power to that coil. It's being charged at a time when it's not giving power to anything, and it's open to receive. And it goes back and forth. It's very confusing, but it works. Okay.
Right. It just looks like to me there's a wheel over there with magnets on it.
Yeah. So
it's switching back and forth from which coil it goes to.
Do you see that?
Right. It goes back and forth between which one it's charging to. And based on that, it'll charge each battery. So the flow goes from the wheel with the magnets on it to each coil individually. As they charge up, they send a signal over to each battery. Is that what you're looking at?
If you see the coils in red when the magnet lands over it, the one that's horizontal, and it's the battery on the right.
About the rotor with the magnets, it had to have something to turn these things on.
That's the relay, the double pole, double throw relay. It's on the right there. The relay. What do you mean turn it on? The relay is turning it on. There's four switches here. There's two on each battery. There's two poles being switched.
I'm not disagreeing with you here, Mike.
That's very confusing. Most people switch either the positive or the negative. I am switching the positive and the negative at the same time on each battery to each port.
I agree with that. That's not what I'm getting at. Up in the top right, there is a rotor with magnets on it that goes over the coil, putting the energy in. That's what I'm saying.
It's only it's not putting energy in. The coil is pushing the magnet.
The coil making the thing run.
Yes. There's no trigger winding here. You trigger the relay. You don't have a trigger winding. You don't have a trigger winding, trigger a transistor. It's the relay is being triggered. You trigger the relay with a timer, a function generator, or you can jump the positive on the relay and trigger the negative for the relay to energize the relay.
Everybody.
What's up, Mike?
We got Mike Faraday here.
Nathan, when the relay is facing to the right, it's not being energized. It's not receiving the power to activate. When it flips to the left, it receives power. So you just add and remove the power to get the relay to move left and right. So
All right,
that's it.
let's
That's
let
it.
Faraday take over and let's jump out and let's see what he's got to go. What he's doing.
Okay, so let me shed a little bit of light on this. Okay, first thing, we'll start with the batteries. It says not radiant charge a positively charged battery. Okay, so if you're running your motor with a positive charged battery, you cannot swap it. So it's the charge side has to always be the radiant, right? So you would have batteries designated for charging and running the wheel. The only way you can charge that battery properly is to take the battery you charge with a radiant, hook it up to an inverter, and then charge that positive battery back. Now, the reason for it is if you do this over and over to a positive charged battery, eventually you'll kill it. So that's very important. So as far as Myke's circuit is concerned, it will work, but eventually the batteries will die out, because if you got a positive charge running the system, you can charge a negative resistant battery. That's okay. But if you're trying to charge a positive into a positive charge, you'll eventually kill it. So he made that very, very clear. And that's where a lot of people seem to go wrong. Now, as far as his circuit's concerned, there's nothing wrong with it. But you have to have positive charge batteries running the system and negative charge batteries receiving the power. This is very important because that radiant
this
spike.
circuit assumes that that's what's going on here. The batteries are already radiantly conditioned.
Yeah, but you can't use a radiant charge
Yes, you can.
battery
You
to
can
run
run
the
a
motor.
coil off radiant energy. I've done it plenty of times.
He
So
says you
please
can't.
explain the radiant charge battery.
What do you mean? I've swapped batteries back and forth. What do you think I was swapping? A radiantly charged battery. How did I charge
Eventually
that
it-
battery that I swapped? It got charged with radiant. Then I swapped it and
Problem-
ran it again off of the radiant
Okay.
charge.
Okay.
So what do you
if
mean?
You listen to if you listen to the energy from the vacuum source, he talks specifically about this. All right. He says when you get that battery you want to charge with the motor, he says you have to kill it completely and then rebuild the battery with the radiant spike in it. You cannot mix a positive spike with a negative spike. You can't mix it on the charge side. You could run a positive charge battery on to drive.
Well,
Cannot
where'd you go?
put-
Come on. Well, sorry. Hold on. There we go. We got you back. Sorry.
Somebody got dumped.
The spike has
Oh,
a positive and negative side to it, Myke.
According to Bedini and his videos, I've watched him extensively. He made this very clear.
I mean,
And
you say you can send a positive end of the flyback to a battery without connecting the negative, and that battery is going to receive it?
It could only receive a negative charge. Like if you're using a positive charge battery to run the motor, that's fine. Then the negative spike that's coming off that motor, that battery has to be conditioned to receive a negative spike.
Yeah.
So if say you got positive energy in that battery that's receiving the negative spike, eventually you will destroy the battery.
Right. I know that.
So as far as your circuit's
But
concerned,
that's only
it's fine.
that's why you drain the battery some.
You have to drain the battery almost down to about, he said, at least 3 volts. He says you have to kill it.
Yeah. So whatever. I mean, that would work great. You know, if you drain the batteries down and then
let's talk about the reverse. Now the battery that's running the system is positive. Okay. The only way you can recharge.
No. In this system, it's supposed to be running the system off of the a radiantly charged battery. That's what you see. You can imagine that it's being run off of a positively charged battery, but that's not what I drew out. I drew a system where the batteries are radiantly charged and running the system. And that's the way I imagine it. Of course, I don't imagine it working very well the first time off of standard charge batteries. If you put them in there, probably you're going to see, I don't know. Well, you'll
Now,
see.
as far as
It might
now,
even
as far
condition
as
them to be radiantly charged instead.
right.
I mean,
So
I've never
as
built
far
it.
as
Just a prototype, unbuilt.
yeah, as far as the battery is concerned, now to restore the battery, say you got a really dead battery, hasn't been used in 5 years or whatever. Okay, you put that on the Bedini motor to receive the radiant spike. Now, it can take several days to actually desulfate the plates and rebuild that battery from the ground up. So that's totally possible. I've heard of people saying it takes 2 weeks of radiant spiking of that battery to restore some capacitive value in the battery. Am I the only person left? Everybody's
I'm just moving things around. Sorry, kind of new to this. Trust me. I just
That's
wanted to
okay.
listen to what you had to say. That was it. So
Yeah.
just go on.
Yeah, so like I said before, you can take a battery that's been sitting around for 5 years that's completely sulfated, and it could take up to 2 weeks to restore the battery. And he does say pretty bluntly that some batteries cannot be fixed.
Okay.
So yeah, as far as running the motor, he always ran his motor with a positively charged battery.
So this system is 2 batteries and a motor.
Right.
Okay.
Right. One's running the system and one's right. And one's receiving the radiant spike.
Okay.
Okay. But the one receiving the radiant spike has to be conditioned to receive a radiant spike. That means you have to kill the battery completely down to like 2 or 3 volts, and then you cycle charge it again with a radiant spike.
So you're building it with different energy.
That's right. It's a negative energy. So, like you have your line, and if, say, like in an AC circuit, you have the waveform going above. Okay. Well, in the radiant charge battery, all the values go below that line.
Okay.
It's a polar opposite of the positive, right?
Gotcha.
So after that's done, he says you cannot put a positive charge in that battery anymore. If you do, you could destroy the battery, and he has destroyed batteries in the past. Even Rick Friedrich, same thing. He says exactly the same thing. You'll kill the battery. So as soon as you charge it radiant negative, it has to stay radiant negative.
Okay.
You're not, right? So
what does it do to the acid inside of it? Is it just spilling over at that point, like the battery would?
Well, you're polarizing the electrolyte. So when you start rebuilding that battery, the idea is to put enough power in it to create almost like a boil. The electrolyte inside the battery will actually come to a boil. Okay. And that's when the desulfation of the plates happens. Okay. So if you're restoring an old battery that's sulfated terribly, it will take maybe up to 2 weeks of cycle charging that battery to get the sulfation off.
Okay.
And with a little luck and a little prayer, you will restore that battery. So
it is putting out some kind of a pulse to those posts.
Sure.
In order to get rid of all the stuff off the internal.
It's almost like you're putting a piezo transducer inside your battery.
Yeah, that's what I was saying.
That's exactly
like a cleaning machine.
It's a cleaning, but it's an ultrasonic spike. High frequency, high voltage.
I mentioned that to Gerald to put it in there in like a saltwater battery and show the corrosion on it.
Sure.
And then it comes right off of there, and it makes just a cool effect, foggy water and everything.
Yep. It's one of those systems that you have to read and watch those energy from the vacuum series when he talks about the back spike, how to contain it, how to cycle it, what batteries to use, what batteries not to use. He gets into great detail, and you have to make notes because there's a lot of stuff you can miss.
Yeah.
Right.
I noticed that with a lot of these things here. There's just that one little part you have to figure. You know what I mean?
Yeah, exactly. Like I've watched like every single Eric Dollard video probably about 100 times. To understand electricity. That guy was my teacher in the beginning.
That's what I
And
did with Gerald Moore and stuff.
yeah, even with
I watched a lot of that.
I think, going with Eric Dollard is good because it teaches you the fundamentals of electricity. You go to half the electrical engineers today and ask them this one question: what is electricity? I will almost guarantee you every single one of them will get it wrong.
They'll probably tell you about AC or DC. They won't know anything about anything else.
No, what is electricity? What is it? No engineer that I know of knows the answer. And the answer to the question is dielectricity and magnetism. You cannot have one without the other. They work conjugate in duality together. That creates that effect of electricity.
So it's like a magnetic bolt, is what you're saying, basically.
Yes.
It has to pulse in order to work.
Exactly. You have to have a dielectricity and magnetism as one. The second you put electricity through a wire, a magnetic field forms automatically. Automatically. It's they're one in the same. And
my God, if I could tell you how many times I try to tell somebody how that works.
Yeah,
they
give you like, what the hell are you talking about? No idea. It's not even taught in school.
They don't even tell you that the frequency changes the volts and amps and something, and that you could change just about anything you want if you can manipulate any part of the circuit.
That's right. I can get all the amps I want just by voltage. Yeah. Like if the original Tesla coils that he made with rotary spark gap, okay, he was getting amperage up to 2,500 amps.
Oh my God. That's crazy.
That's a lot of juice.
Yeah, it is.
And it's high frequency, high voltage. They'll give you a huge amount of amperage.
That's just uncomfortable.
See, in my motor, I've implemented basically a large coil. I'm using the radiant spike, and then I'm bouncing it off 2 piezo transducers.
Okay.
I'm getting the ultrasonic frequency spike. It ricochets back and creates a reactance in the coil, which also multiplies it by 30 times.
Okay.
So my motor, I was running a little 9-volt batteries, 5 of them. I've been running my motor for 6 months with the same batteries. It's still running.
That's the same one you showed last time, right?
Yes, yeah. I could run my motor with dead batteries, and it just keeps going and going and going and going.
So let me ask you, what are the batteries doing in the system? Are they taking a charge, giving a charge out of it? What are they doing in the system?
They're creating a voltage potential. Okay. My motor is designed to run on almost zero current. The current is generated in the coil with the reactants. That's where the power is generated. I'm using a seed power or voltage from the battery, and the second I steal that power for a split second, my switch shuts off. Now, I use a mechanical switch. The second you release a mechanical switch, your resistance to the ion flow from the battery goes to 0.
Okay. That's amazing. So you captured the energy.
I've captured that energy, but I haven't pulled current from the battery.
Right.
The second about the radiant being the killing the transistors. Remember you asked me that, Nathan?
Yeah. Hold on. He was explaining his motor real quick. Let's let him finish.
All right.
So the second you release a mechanical switch, a lot of people don't understand it. The second you do this, the resistance or the flow of the ions from plate to plate in the battery stop before it even leaves the battery. That's why my batteries don't die.
Oh.
That's what Bedini's trying to tell everybody, but nobody's getting it.
But with Bedini, and this is where I disagree with Bedini, you can only accomplish this with a mechanical switch, never with a MOSFET, SSR, whatever. You will not get the effect that I'm getting with my mechanical switch. I've been able to engineer my switch to fire extremely fast and very precisely, where a lot of people say, oh, no, you're wasting power. No, you're not. No, I'm not, because my battery's not dying.
So
Why
when
is
you
my
say
battery?
switch, is that your spark gap?
Yep, my spark gap switch.
Okay.
The second that release happens, the current flow from the battery ceases. But I've now got that radiant spike, now enters my coil, creates the inductive reactance, hits my transducer, bounces back into the coil, and multiplies it by 30 times at least, and then exits the system through a diode.
So that's the amplification Gerard Morin was describing when he used
That's
the
right.
spark gaps in the system.
Exactly. He's
Mike, how do you
100%
control your
correct.
frequency?
Frequency, speed of the motor. That's it.
The
That's
spark
your
gap.
frequency. The spark gap is controlled by the pulse. My motor's always usually 4 magnets per 360 degrees. So
What's triggering the spark
four,
gap?
that's what triggers it, is the magnets
magnet.
off. The magnets trigger.
That's
The
how you
spark
control your
gap
frequency.
is the amplifier in the circuit.
That's right. It can,
Brings it up.
yep.
So you're using the
Right.
magnetic field to trigger the spark gap. Okay.
The magnetic field's all generated in the coil. All the
I
power
mean,
is
the field
generated
from the
in
magnet
coil.
coming to the spark gap. You're
No,
using
no,
that.
it's just a triggering mechanism. It's a triggering and timing mechanism. That's all that wheel
A
does.
function generator.
So how do your amps come out on the other side? So if you got milliamps coming in going through the spark gap, right? What
Right.
do they come out in the end? Is it a lot lower? What's the
Oh, it's a lot higher because of the inductive reactance that's in the coil, right? That accelerates the electron flow in, because you got that back spike. Everything collapses and then wants to go out, right?
so is it creating a vacuum to suck it into the other side?
Pretty much. Yeah.
I think what your
creating a-
spark gap is on the negative.
My spark gap creates, well, yeah, it basically makes the
And you're
current flow
triggering
from
the
the-
positive with something else.
Well, most of it's happening in the coil. The spark gap switch is just controlling the flow of ions from the battery to the core, right?
Giving you your duty cycle.
That controls the duty cycle and frequency.
What are you using? An optocoupler and a function generator? What's controlling your frequency?
Well, I use the 3D printer proximity sensor. So every time, every time
Uh-huh.
the
magnet
spins
passes
around.
that or whatever, and then
Yeah, it's 180 degrees out of phase.
right. So you isolate.
Yeah, I gotta
The
love
timing
the way
right.
this
You get the
thing
RPM
works.
just right. Yeah, you get a huge amount of inductive reactance in the coil.
Interesting.
But the release, the break in the switch is key. It's really key.
So you're removing heat out. Where'd you go? You're removing heat out of the
Okay.
system while you're spark capping it.
Yeah, there is no heat because it's a negative energy spike. You never get the heat. Like, if anything, my coil goes. I've recorded as low as 9 degrees below ambient.
So he, instead of a transistor, he's using a spark gap.
The spark gap switch, yeah,
Yep.
or the 12-volt automotive relay switch. And I've did a little mod to it, so it'll trigger fast.
But not both, not the relay and the spark gap, either or.
No. I just use the spark gap switch,
Right.
which is
And when
the
you're
automotive
phase
relay switch.
when you're phase shifting at 180 degrees, that just means you're feeding it backwards, or is
Yeah.
that just yeah?
Yeah, it's on the rebound backwards.
The
That's
flyback?
right.
Okay, just clarifying.
Yeah.
'Cause,
Now the other.
I heard. No, I was just
Sorry,
saying
go
I
ahead.
heard the same theories in the rodent coil research circles, so that clarifies that for me.
Right. Now, as far as the spark gap switch, now, if you get it timed just right, when you have that release in the switch, another great effect happens. Now you defeat lens law. There's no cocking of the wheel. There's
Would
no
you say
lens
you're
law.
reversing it?
Well, automatically when on the back spike, the field of the coil reverses itself.
Am I
But if
explain
you
why
get-
it gets faster as it speeds up? Because as it speeds up, the switch is quicker.
Yeah. Oh, yeah. It goes faster. It changes frequency, right? So the faster
Because
you
the switch
switch
is
it, your
dependent on
frequencies
the
go
magnet
up.
passing the core. Switching.
Now,
Right.
keep in mind too that back spike is hitting 2 transducers.
So theoretically, when this system is stabilized and running, at a stable RPM, you can turn down the input power and it would still maintain that stability, right?
Pretty much, yeah. If you, yeah.
The faster
That's
it spins,
pretty-
the shorter the duty cycle.
That's right. Yeah.
That's
Means
now
less
if you-
that's
power
very
being used,
important.
but
For,
or the same
Now-
amount of power because your
Now,
frequency is up.
if your RPM goes too low and your duty cycle's too low, you could actually burn the switch out. So you got to get that sweet spot.
I'm
I find about
didn't hear that last part.
400. If you go too low in the RPM, the duty cycle goes too low. The spark gap switch will actually start to heat up, and you could actually burn it.
And the
Because now
slower
it's
you
drawing.
spin, the longer the
Right.
switch stays
Right.
down.
So you want to keep it optimally between 6 and 750 RPM. That's optimal speed. So with that, the coil stays cold, the switch stays cold, nothing heats up, and it runs very consistent.
So let me ask you: is this a cold energy circuit, or is it still on the hot side?
No, it's cold, 100% cold. I've recorded 9 degrees lower than ambient on the coil core.
9 degrees. Yeah, that's when I was doing research with cold electricity, it was around the same, about 10 degrees colder than the surrounding ambient.
Yep, definitely. It works. But see, like everybody thinks I'm crazy. Oh, you should be using MOSFETs, SSRs, and whatever. It doesn't get the same effect, especially if you have a transducer. If you got a transducer hooked up to it,
Yeah, I figured
getting,
you were doing that, G.
you
That's
get
a
a
great
30% gain.
See how far you can keep that flyback going into a third coil
Yep.
even. I don't think it'll go past the second coil though.
Yeah, like the transducer helped my system by 30% right off the bat. About 30 to 50%. That was a game
This is a
changer.
piezo material.
I use barium
And you know that
titanate.
radiant flyback is a great piezo stimulator.
Exactly. Why do you think I'm using it? That's why I got such great results with it. Got amazing
Ultimately,
results.
you want to send
Oh
a
man, what
flyback
happened
signal
to
into
Bruce
nice
face?
big square plates of some specialized piezo plates,
Well, the ones I got, they're 2-inch diameter by about, I think they're about 1/16 of an inch thick. They're barium titanate. They work great.
I think the future of energy is going to be landing on, piezo material research.
It is.
That's
It is.
not really focused on. They're focused
Only
on
gonna look-
perovskites now for solar technology, which
Solar
is photo,
obsolete.
collecting materials for photons. But what about
Photovoltaic.
piezo materials for sound waves? Photovoltaic.
Sorry about that, guys. I'm just kind of like shuffling around here. I'm doing laundry and doing a podcast at the same time.
Oh yeah. Gerald over there, he's telling us, okay, the difference between his system and mine is that he collects the back feedback. Let me put it up here, guys. Is that he collects the back feedback spike. So Gerald's collecting in his coil the spike that comes back.
That's right.
That what I'm
he's
seeing here?
energizing one coil and it's reversing polarity into another one.
Yeah, it went off.
That's interesting.
Yeah, the reverse polarity is usually thrown out because it damages circuits, or they short it out somehow, like Bedini said.
The coil isn't wasting anything; it's taking all of it.
Right. So he's using another coil to absorb the radiant that the first coil generated.
Because he has multiple coils
Right.
in the one big coil. So
With
smart.
specialized piezo materials between those coils, you can get the second coil that got hit with the flyback to vibrate more and continue on to the next coil. But you need piezo materials for that.
Yeah, you use barium titanate. Barium titanate's the best. Yeah.
Oh man, what's going on? Okay,
Like a copper coil with piezo material on it.
What I'm seeing like a coil charge, and then while it's charged, it's charging a secondary coil with it, right?
No.
You could even hit a
It's
third
charging
coil with one pulse.
first, removing the charge. Unless he's giving it AC.
So, to my understanding, unless I'm wrong, piezo material is just stacked neatly, with the atoms stacked neatly. Is that what's going on with it?
Piezo material.
Yeah, it's creating a lattice structure.
Barium.
You're creating a lattice structure.
Would it be possible to synthetically create that in a lab and apply it like in specific geometries?
Yes. You have to figure out a way to layer, like say, for instance, another naturally found piezo material that's highly piezo, known as quartz, and find ways to layer quartz. Maybe, I don't know.
So and that would be a way that you could
amplify the piezo effect of the quartz naturally by, as you suggest, layering it correctly.
So that would be like you can enamel a wire like that.
I mean, barium is also a piezo material.
And then we know like resonating or applying a specific frequency or electrostatic pressure to the piezo material.
Right. It could be certain frequencies. Right? They trigger certain materials and better this frequency for that material and different frequency for another material. It's the resonance of the material, whatever the material's resonant frequency is, which boils down to the material's dimensional geometry of the singular molecule of that material. Whatever the dimensions of that singular molecule of that material is, that's your measurement you would use to determine the resonant frequency of that material.
Yeah, like the one that I use specifically on my motor, it's about 42 kilocycles. That's what the barium titanate resonates at. So because I got that high frequency there, it's actually putting my coil for the motor into harmonic resonance really fast.
And that isotope of barium isn't radioactive?
I mean, you could probably look up what is the resonant frequency of barium,
Well, it varies from transducer to transducer. I know mine are at 42 kilocycles.
42K?
Yeah.
Is barium?
Yep.
Sounds right. I mean, it's in the kilohertz.
Yeah, and that's why I get such a huge inductive reactance in my coil.
That's interesting.
How did you get up to 42K?
Because you got the ricocheting of the back EMF spike coming off the coil.
Oh, so the barium itself is creating the 42K.
Yes.
Yes. Nice. See?
I believe John Hutchinson.
You know what that is? You know how they do that traditionally in traditional circuits? It's called a crystal oscillator.
Yep.
So Myke is simulating a crystal oscillator. Effect.
That's exactly what it is. That's why I got a 40 to 50% gain.
The barium is his crystal.
Yeah.
Yep. Yeah, so I believe John Hutchinson in his crystal battery used beryllium.
Well, here's the thing about crystal materials, no matter what the material is. If you have a crystal material that's 1 centimeter square, it's going to give you, let's say, what's the dimensions of 1 centimeter? That's like a frequency the size of 1 centimeter, whatever that frequency is. That's like, I don't know, a kilohertz or something.
It'll probably go higher. I know mine go.
Material just once, and this is how they make crystal oscillators, by the way. You shave it once, and you change it to 999.9 kilohertz.
Yep.
I'm sorry, 900.
You're altering
0.9999.
That adds up because the angles and the dimensions of
a little less of a kilohertz, or no, your frequency goes up. The smaller the crystal is, the higher the frequency. So I'm sorry.
That's right.
You would go up
That's
from
right.
1 kilohertz to like 101 kilohertz.
In order
When you
to
shave it a
calculate the
little bit.
resonant frequency of a material, you have to add up all the angles.
Yeah, it's
Right,
the
but there's
lattice
ways to
structure.
read that. Oscilloscopes can read the crystal oscillating because they oscillate naturally.
Hmm.
That's
right. Yeah, they release a natural oscillants or
right.
frequency. Right.
So they hook an oscilloscope up to the quartz, to the crystal oscillator, and they keep shaving it till they get to the frequency they want or whatever, and then they mark that frequency on it and close it up and sell it to you.
See, the best part about it is you can control that frequency with the RPM of your pulse motor. So you have full control over this frequency that the
Or as you're
transducers-
doing it with a solid state piezo material,
That's right.
which is not being controlled by any motion. It's being controlled by the material.
Right, and the pressure on the material.
No, the vibration of the material, it's got a piezo property. It vibrates.
Right.
Right,
That's
but the
right.
vibrations create an electrostatic pressure. That's what I mean.
Yeah, it's creating that by the back EMF
Yeah.
flying off the coil, and all that back spike from the coil is now hitting the transducer. Okay, so you can imagine the reaction that you're getting. And because it's such a violent reaction, it actually goes back into the coil one more time and multiplies and then comes out again. So you got this series of shock waves going backwards and forwards.
Comes back in from the barium into the coil,
Yep, it goes
and then back
backwards.
into the barium again.
Yep,
So yeah, if the barium is going to piezally vibrate stronger than your initial pulse to that coil, then you have it. You're done.
so what I do is I put, after the transducers, I put a flyback diode facing out. So now all that energy I just accumulated in that two components is going to give me a hell of a lot of power coming out.
So you're getting a
why-
burst of energy from it.
Huge burst,
Nice.
huge. Like I've recorded
Nathan
high
likes those huge bursts.
Well, the huge burst I got, the largest I've ever recorded on my meters, on my oscilloscope, is about 762 volts.
Guys, I do high voltage all the time. So anytime that voltage flies, man, or you get spikes, I just get excited, okay?
I'm an electrician. I got over that. It's cool though.
Oh,
But it's but
if
but
you were in
you
my
heard me
garage, you would think it's cool all over again.
It's
Yeah,
You
cool
heard
if
me on
don't
the
get
live
shocked
stream
by
last
it,
night
you
when
know?
I popped that capacitor.
Oh,
but the thing is, what's most amazing of all, I'm using less than a half a watt of input.
say that again?
Yeah, that's not a lot at all.
I'm using less than half a watt of input energy to get that.
Do you know exactly what the current and voltage is?
Well, the current basically is 0.0001 amps. Some of my meters, some of my meters won't even register it because it's so low.
That's in the range of the vacuum triode amplifier. It was like less than a third of a milliwatt of power.
Most of my meters will not show a reading. I have to put it on the oscilloscope.
They can't read these flyback spikes. You need an oscilloscope, right?
So
It's the only way to
that's
see it.
where-
Or you can use a neon bulb.
Yeah,
You know, I was got to tell you, Ben, you really need to look into that trigger circuit. It's going to change your life. It's $8.99.
Yeah, I'm gonna definitely order some
Get
of those
some
parts.
coupons in there, maybe, if you need them.
No, I'll be able to stock up and
Nathan,
definitely get something going for phase 2 of testing.
Yeah,
That's
what I
gonna
was
be
trying
really
to tell you yesterday, you got a stereo, right? So
Yeah.
you basically put any frequency you want. Okay.
Mhm.
Now you also have sitting right there is a bench power supply. The
Right.
trigger circuit actually lets you use the 5 volts from your amplifier to put the frequency in to the voltage that's coming through your power supply. So now you can now put some true power through this thing and see what the numbers are. My concern
So you're saying
was,
I can hook up the stereo to the workbench power supply and produce the tones
through
that
the
I need.
trigger circuit, yes.
Wow.
Because it'll keep the low side low and the high side high,
That
but it'll
is
bring
going
the
to change.
frequency over to the high side. So,
That is definitely going to change everything.
so what it does, it allows you to add amps to your system and find out what you really have. Because when you're dealing in milliamps, sometimes it
Right.
lies to you. So you
And
know what I mean?
my workbench
Unless you're
is pretty
directly
accurate
dealing
too.
with them.
Right.
Yeah.
My workbench is pretty accurate and it allows me to tune it, not just the amperage, but the voltage as well. So I don't know. This seems like it could be very,
because you're in the flow of energy and they cross each other. I keep telling you this. That spike should be good. That's right there is an amplification point. And that you
Right.
can't get it without like 1 to 2 amps. You know what I mean? When you're in
right.
the
So like
milliamps,
what I'm
it's
doing is an
amplification.
approximation with my system right now. This is going to be precise.
Right.
Gotcha.
You're going to get some numbers in there that drive you nuts. That's why I tell you play AC/DC, Thunderstruck, and rock and roll, man. Just see what it does, because
Yeah,
it's going to drive your voltage absolutely nuts,
Hey,
because it's going to bring
you
up
see
volts,
what it
bring
did?
up amps, bring up volts. It's just going to go like that all day.
It was weird when I put the neodymium sphere in. I just have like a Teflon plated pot, like a soup pot, and I put it in the pot and I put it on the coil last night, and I blasted one of the songs on my playlist for the channel, and it blasted the pot off of the table, but it magnetized it for a second. Like the ball was stuck to the side for just a second. I'm like, what the heck? Like that must have been a big spike in power.
Because you don't understand, frequency is changing your volts and amps. So you're magnetizing stuff, whatever material's in it, you're magnetizing it, because you just took all the volts out of it and threw straight amps into it because the frequency changed.
Okay, that makes sense. Yeah, and the frequency changed so suddenly with the music.
That's why I'm saying. You get me now. Now you get it, right? Now we can throw out some AC/DC and have some fun.
Okay. Definitely. Hey, on Twitch, we can definitely do that. We won't get hit with a copyright if we do it on Twitch. I swear to God.
Well, what I'm saying is, even if you do it in a pre-recorded where you don't let any of the music out, as long as you
I can do that too. Yeah, I can do that too. That's a good idea.
I want to see what that neodymium magnet does.
Right.
It spins now, but is it going to try to counter spin? If you mark it, is it going to, which way is it rotating? You know what I mean? Which way is the flow going at that point?
That's another good idea. I should mark it so I can see which way it's spinning.
There you go.
Oh, these are good ideas. Nice. Thank you.
Yeah, well,
this is definitely the Fringe think tank.
Well, you get some ideas, because I run high voltage because it likes to take all the lies out of my system. Even if it's just for show, what it does is it tells me if there's a vortex in there. It's going to tell me which way, if I'm getting charged or if I'm getting magnetism on something. It's also going to tell me immediately when I change the frequency where the volts and amps are, because I
like that because you can see it visually. It's a visual confirmation. I like those.
Exactly. So you don't have to run your circuit that way. You just have to know it when you do it. So that's why high voltage helps us see it.
Right. And that's how you become in tune with your system itself and become intuit to it.
That's why these guys that are doing these things are actually just tearing it up, because they know the little nuances going on here. And
they know exactly how it works. Yeah,
as soon as you can pick those out, man, you're going to make this thing just hum, man. It's going to be awesome. Because every time you get an amplifier, you want to keep that, but add another amplifier somewhere. Then I always say put a capacitor in there. You want to retain the energy. You never want it to dissipate.
the Nunez circuit does have a capacitor. It's not it's in one of the diagrams, but I did get for when the time comes, I did get what they recommended was a 2000 volt capacitor. So a nice big expensive one.
Oh, just take a small one, put a diode before it, let it channel it one way in, okay, and let it build and see what you can get inside the capacitor.
So I don't even need a big expensive one. I just need a small one. Well, how small are we talking about?
Just pull something out of some kind of machine you're going to throw away.
Oh, well, I got a bunch of Arduino capacitors, like 50 volts, I think.
Yeah, look.
You think that would work?
You're not running high voltage here, so a little capacitor is fine. What you want to do is, like I said, take that diode, make sure it flows through the diode into the capacitor and is not allowed out, so you could charge a capacitor. Then you could just take a time test and see how long it takes to charge the capacitor, right? But all of that is free energy to the circuit that you're not, you know what I mean, throwing out, or it gets lost in the wire or something else. Now you've got some way to capture it.
Right.
And if you can spike this, okay, so hear me out. If you could put a coil under this and you can spike the crossing waves of your coil, right? And you could put a coil under it to catch it. You could take all that and put it into capacitor. Then you could put a coil on the side. You could put a coil on top. You're catching more energy because of the flow.
So I can have a driving coil and then a pickup coil. So when the secondary,
not like another coil just like yours, but like a flat coil. Okay, you can get away with that.
A flat bifilar or just regular?
Just a regular coil would work fine, just so you can see how it works. Okay, but it has to be flat, like a pancake,
like an induction coil. I've seen those.
Yeah,
are flat.
well, however you want to say it. I mean, you can use a bifilar coil. What I'm saying just is the whole thing is find a way to put a coil next to it to pull the energy. Put a coil in the center of that sucker.
Is it more about the geometry then of the pickup coil?
There you
go.
That's why I see that coil inside of a coil. That's all geometry. All of it.
Now you're speaking my language.
I play pool using geometry, man. Trust me.
So when that
don't play pool with me. I'll shark you.
When I get the second coil built, I do want to test the wireless power transmission experiments too, because those coils supposedly have the ability to transmit power between them wirelessly. Through inductance, just sitting on top of each other.
When you have a small bifilar winding coil and you could put right down the center of your main coil, I'd love to see the numbers coming off of it.
Yeah, like you said, it's going to try to amplify that spike.
Yeah, just like it's rotating the magnet, you're going to put energy into it. So I'd love to see what the energy looks like.
Yeah, that'd be interesting.
So that's the way I would do it. I would start testing things around it.
That's a simple experiment too, because that's not that hard to find a coil like that or make one if I had to. You know what I mean? Like that's not it's very involved.
No, it's fairly easy.
Well, you want to energize the PoE coil with another coil.
You just want to run your regular coil, right? His coil, the rodent coil, and then put a coil next to it in different places so that you can get the energy off of it.
Oh,
wherever it's spiked.
Use it like a stator.
Pickup coil. Yeah.
So you're stealing energy is all you're doing.
Like you know how Gerald has the pickup coils around his main coil.
Yeah, that's a given. Everybody should do that.
Yeah.
You're generating a field already, so
that's
right. It's just wasted energy if you don't.
And a small capacitor to keep the energy.
See, the most important thing about that field, okay, the transmitter or the coil that's producing that field, when you extract it from another coil in that proximity, it doesn't tax the power coming off the main.
That's weird, huh?
So you have no law.
It's not the same. It's not the same energy from the main. It's not coming from the main.
It's coming from the vacuum.
It's main energy that's been converted.
Well, you polarized that space between the coil and the receiver, right?
Oh,
That
that too, right,
space,
right.
that whole space is being charged, and any
Well,
other
it's
part,
radiant energy from the vacuum. The question is, how is it coming from the vacuum? Is it coming through plasmoid clusters? Is it coming?
Hold on.
Okay,
You're using
you know what
vacuum in a
barometric,
very loose term.
does anyone ever hear the word barometric pressure? Does that mean anything to anyone?
Barometric pressure?
Yeah, but if you're using that as a metaphor, okay.
Okay, that's a good example of
As a metaphor.
evidence of where it
Yeah.
might be coming from.
You're creating a pressure in
There's a
that
pressure
space.
called barometric pressure. I mean,
Well, you're creating
is that
energy.
pressure not surrounding your body and the electronics that you're working on?
It's surrounding everything.
Surrounding
Well,
everything. It's barometric pressure. It's what creates the weather. It's a reality. It's not myth. It's reality. Barometric pressure. It's a real thing. So you could use that real thing to derive your conclusions. That's what I do.
If you look at one of Don Smith's early devices he made, he had a 1 Tesla coil in the middle. That was the transmitter. And then he had same coils, about 5 of them around it. And it was producing 5 times the amount of power as the input.
Ben's asking now, where does the barometric pressure come from?
Well, it's just
most things in nature, in my opinion, come from exotic vacuum objects, or most power in nature, like giant thunderstorms that come out of nowhere.
I'd say the
RF
barometric
signals,
pressure comes from the
fields,
Earth and it separates in between
neutrinos,
everything else.
I think it's all one. Yeah, it's all one and the same, though. I believe
It comes from a lot of
that's just
different sources.
that's just my theory, though.
I mean, everything else around Earth, there's definitely planets bigger than Earth. And that right there is pressure. If there's planets smaller than Earth, then Earth will be pressure for those planets, but not.
Right. And Ken Wheeler's
the other way around is something different going on, not pressure.
In Ken Wheeler's Secrets of Magnetism, he does describe in his theories of gravity as just a pressure differential in the ether between
mass,
two
density,
points.
Density.
Right.
Not just mass, but the density of the mass.
Yeah.
Well, in order to have pressure in something, you have to close the system. You can't have it open, or else there's no pressure.
And, mass doesn't have to be one object. It could be billions and trillions of gajillions of quantum objects.
The way I think it maybe works is if you're creating counter space backdraft or pressure, you have to have a system where it has inflow and outflow from the vacuum and pinch off one of those poles, I guess, that maybe the inflow.
Well, why is there an in and out? Why is it got to be an in and out? That's suggesting that there's a beginning and an end to the cosmos as well when you say that, because having to be an inflow and outflow means there has to be a barrier, an endpoint to the universe.
Well, Bearden talks about there has to be a imbalance. If everything's in balance, then everything just dissipates and disappears. There's always got to be a differential, right?
Differential. There's the key word.
Asymmetry you're talking about. Yeah, that's his theory of asymmetry.
Like a differential or a non-equilibrium.
Yeah,
or a spinning of motion, which could create the differential.
See, if you have an equilibrium, eventually the power will fade out because everything levels out, right? If you have in equilibrium, something's always out of balance, and that keeps the motion.
Well, you could have motion and balance. That's the vortex.
I don't think anything's in balance. It's always a little out.
The vortex is definitely in balance.
Yeah, if you look at nature, everything's always out of imbalance.
It's always got a difference. The leaf always has different ridges to it. There's always something different. It's always
nature doesn't grow in a straight line.
Right. No. So that's the basis of how my new battery cell works on this principle. So I'm not talking too much about it, but that's a little snippet. That's how my battery works. Actually, it's not even a battery. It's not even a battery. It's actually, it creates power
Huh.
through, it creates power through quantum tunneling.
Quantum tunneling. Yeah. Now that's
I'm gonna have to
interesting.
check that out. That's
When are
new
you
to
going to
me.
do a presentation on that?
Yeah.
That won't be for at least a year
Oh,
because
mean,
I'm
you still
under
pull
a
numbers for a while.
I'm under a non-disclosure right now with a partner. So until that's done, you know, it's one of those technologies that basically makes solar and wind power obsolete overnight.
Gotcha.
There
We
are
will
other,
look forward to your
there-
presentation, and we will wish you luck.
yeah, I'm doing the first prototype with a new material this week, so hopefully that will go good.
Yeah.
So yeah, it's
Hey,
look
one
up.
question. Do you have to
Go
go
ahead.
push forward to get a quantum reverse, or no?
Quantum tunneling. There is no energy that's being fed into the system. The ions from the anode, or sorry, from the cathode to the anode, happen on their own. There's no visible means of energy transfer. For some reason, when you have that unequilibrium, the flow happens on its own. So look up quantum tunneling. It'll give you a little bit more in depth on what that is.
Yeah, I got
So
a
you
job.
you make materials unequal to each other. You're kind of like crystal batteries.
It's my cell's going to have about 12 different elements. Yeah.
So are you having a reaction in there? Like it's not acid, reaction, but I'm just saying any kind of
Yeah, opposition to materials.
In the beginning, we thought there was a galvanic action happening, but the thing is,
it's opposition. It's not. Sometimes it's galvanic, but this is silver and gold are not going to galvanize.
Right. There is no electrolyte in this system.
Gotcha. Okay.
So they are.
I don't want to try too much. I just want to know when I look up the stuff.
They oppose each
Okay,
other.
so I brought up the layman's definition of quantum tunneling, and I'm going to read it real quick. Quantum tunneling is a phenomenon where a particle, like an electron or photon, can pass through a barrier or gap that would normally be impossible for it to cross. It's like trying to jump over a tall wall, but instead of jumping, the particle somehow tunnels through the wall without actually crossing it. So it's like going through material that it shouldn't be able to normally go through.
Exactly.
Or what if that's the edge of the cosmos? Does it go through the barrier of the cosmos too?
I don't know.
He's
But we
building
do
Stargate ZPMs, man. That's what he's doing. He's pulling some energy out of nowhere. That's what's going on.
Well, we do see charged clusters go through materials like that based on scanning electron microscope evidence. They just kind of like tunnel through materials randomly.
Yeah. As you see, the beauty about it is there's no input source of any kind. There's no galvanic source of any kind.
Huh.
So
that's incredible.
So now we're getting into particle physics. So I basically slammed my head against a book and started doing an extreme amount of reading.
Yeah. Especially trying to find a material that will
will
be like a superconductor, no?
Yeah, that could classify as a superconductor.
It reminds me of the demon core. You're pulling out energy that you don't think is there, but it's enormous in size.
That's right.
It's like a material that acts like a ramp for energy.
It's creating a bridge.
Like it acts like a ramp for energy. It makes the energy ramp down or up or whatever.
Yeah, that's a good analogy. I like that.
It's creating a bridge.
You know, the energy already has a flow established, but if you can, get it to establish its flow onto your flow, you can,
create that ramp.
Right. I always imagine the path of least resistance being kind of like energy sliding down instead of, you know, crawling against a floor.
Like those conical
Well,
coils, you know?
Well, it goes back to non-equilibrium. That's playing a part in this.
You can imagine a conical coil, though. It'll ramp the electron, compress it closer and closer, kind of like a ramp. You know, not, you know. It's all the same, similar. You're trying to create the flow. You're trying to not create the flow. You're trying to stimulate the flow, like sticking your hand in a river and catching all of the force by turning your hand a certain way, the right degree or whatever. That's basically what we're trying to do with material science, and
Right.
how energy naturally flows like water in a river over these materials.
Yeah, it's just all particle physics.
Now hold on. Let's just make a dividing line here. So we all seen plasma channels, and he takes water and it makes a bridge across the water based on the voltage. Okay.
Yeah.
Now it's not that, right?
Nope. There's no water in it.
No, I know there's no water. I'm just saying it. That type of energy. Like I could take a magnet and put air in between it and energize the air and magnetize it.
Sure.
Is it something like that?
Yeah, you're from the cathode. That's your donor plate. So you have particles.
Yes, but not with air. With quantum.
No.
With the quantum.
We're talking. Yeah,
Instead
we're talking
with air, with the quantum instead.
Yeah,
the
exactly.
quantum realm.
So air without with the quantum
using
instead.
piezo materials to tune into quantum activities.
Right.
Which is not air. Quantum is,
it's smaller. I understand. I'm trying to rule things out. Okay, I'm whittling down here.
So basically what you have is a donor plate, right? That's going to give up free electrons, okay? When it gives up free electrons, you have to create a bridge from the anode to the cathode.
To pull
right? To pull it, to create that non-equilibrium. When that's achieved, those particles coming off the donor plate will now go to the anode. And there you go.
That's
right. You're creating the non-equilibrium, and the energy wants to find that equilibrium.
Using different metals on one side or the other of the semiconductor.
You're creating the waterfall.
Right.
Yeah, there you go. The waterfall. Yes, exactly.
Gotcha.
The water's already falling, but you need to, create the bucket or whatever.
Yeah.
So we have somebody at Dimethyl said, you can tune a Tesla coil, but you can't tune a fish. Nice dad joke there.
Yeah. I'd like tuna.
Yeah. Tuna
Not
fish.
a tuna guy.
Yeah, tuna fish. I just got that one.
Oh, yeah.
You just got that now.
Yeah. I was like, tuna fish. How do you tuna fish?
Yeah.
I'm a little slow with those semantic jokes.
It's okay.
It's okay. It's okay, Mikey. We're not judging you.
That ain't right. Okay.
But yeah, so I like to talk about it, but there's certain aspects I can kind of give you the overview of how it works. The materials used, I cannot talk about because I've been working on this for already almost 2 years.
Well, we don't want to get you in trouble, but whatever you can lay out there would be cool.
Well, that's kind of the basis of what it is creating that non-equilibrium between the anode and cathode, creating a waterfall effect from the donor plate. Now, it's key to have certain elements in the donor plate that allow that electron separation to happen. So I'm just kind of giving you the physics of what we're actually trying to accomplish in the cell.
So is there any resonance in it? Anything else that would separate something from another thing when two plates are together?
I have recorded a back EMF in it, believe it or not, which that took me totally by surprise.
I read something or saw something somewhere where they say all materials, once given a charge and that charge is removed, will reverse polarity.
Just to kind of give you an example of the power that I'm getting out of this, I'm recording about 1.7 volts at about 17 amps.
That's good. Yeah, that's real good.
1.7 volts at 17 amps.
17 amps is incredible.
Yeah.
So hold on. If you're getting amps out of this, you're
volts?
getting heat out of the system. So therefore, you have to have two things that are chemically divergent from each other, connecting together in order to create the
About
imbalance.
25 watts.
No,
You got it.
You got heat.
Yes, sir.
You got heat. That's the missing factor. You got heat.
Yep.
So if you know anything about energy and you know how to flow it, we change the frequency, you change the amps, change the volts. You'll understand by adding heat in it, you're getting magnetism in it. You're going to get, a whole lot of other myriad things. You're going to get a very low frequency out of this thing, which has to do with the flow of it.
Yeah, and when that reaction happens, the plates actually expand. So you have to get the chemistry correct. There's a few elements which I can't talk about. If you don't get it right, it'll fracture the plates or completely destroy the cell.
Yeah.
So when that expansion happens, the expansion's about 300 times.
Oh my God.
Yeah.
That's bad.
Yeah.
That's some shielding going around that thing. You need to save yourself.
Well, it depends how you use it. See, this cell, if you pull a continuous load off it, you'll destroy the cell. It has to be pulsed. So this, when it's done, it'll actually have to be pulsed. Now, if you make 6 or 8 cells in series, you could have one serious power source. And right now, me and my colleague are, we figure we're going to have anywhere from 5 to 10 years life on the cell.
Wow. Well, if you get it any bigger, it'll almost be like a thermite reaction. You know what I mean? You'll just, because of the heat, you're going to just burn through things. So,
that's part of the material science that we're doing right now that will circumvent and protect the cell.
Okay.
So that's all. We've already went through all this stuff methodically. We know there are other people out there that are working on something similar to what we're doing. So we've done like cross references from other people that actually have some patents out there. We're doing something similar to it, but a different makeup. But our cells are going to put out some major horsepower. Now, the thing is it too much horsepower? Do we have to engineer the cell to go down to, say, 2 amps instead of 17?
Well, yeah, because you have to balance the amount of material there versus the energy taken out, because you're going to have a finite amount at the end, right?
Right, and it's also going to help out with the life of the cell. So if you have a controlled reaction there, instead of getting two years of 17 amps, if I drop it down to 2 amps, I could get 10 years.
Yeah. Exactly.
Right? So that's the stuff I'm working with. I've been very hush-hush about it. I'm not really going to get into what materials I'm actually using. But that's a pretty good overview of what I'm working on.
Well, the change comes in. Okay, check this out. If you take something like Gerald's coil and you put it after that battery, or you put your coil after the battery, then you really have a good amplifier afterward, right? Because then you could take the energy, save it, charge it, amplify it in different directions and have a full potential, then convert that potential into usable energy.
Now, here's a really good, cool characteristic of the cell. When you stop drawing a load off it, the battery goes into or the cell goes into a dormant state. It goes to sleep.
Well, you can't ask for more than that.
Yeah. So the
That's
second you start pulling a load off it, then it comes alive.
because you're
And
stopping the chain reaction.
That's right. You're got the cutoff valve on the waterfall.
Oh, yeah, you're definitely working on something cool, man. That's for sure.
Yeah, this one's probably my most intense build.
Like a life-changing build is what it is. That's
Well, there's some people out there that have done it and have had great success with it. I personally think this is a real alternative to actually using solar or wind.
okay.
And it comes in a very small package. Like the plate itself is less than an inch thick. You put 6 or 8 of them together in series, you get some serious horsepower there. Then you use that to charge up batteries, and they can run the inverter. And like the system that I'm currently working on should sustain a 4 kilowatt system.
Okay.
Wow.
Yeah.
Yeah, you definitely want the design of the system to be simple and replicatable for sure.
Oh, it's so simple, it's ridiculous.
I love to hear that. No, that's awesome.
It's ridiculously easy. Just take your solar system that runs the house right now, remove the solar panels, and put my cells in its place. That's the system.
That's awesome. That's really cool. I'm all about the alternative energy research.
So all the components, all the hardware is commercially available. Everything, even the cells itself is commercially available.
Wow.
Yeah. Because I have graphite that I've been experimenting with that came from a nuclear reactor.
Oh,
so it's like I thought. It's all off the shelf components, but it's the way and methodology that you utilize.
yeah, not the nuclear reactor stuff though.
No.
I'm finding that on the shelf.
Yeah, exactly. Well, yeah, Fred, my partner has a connection with Ontario Power Generation, and they use these graphite plates to actually cool down the reactor core. So they're very, very high grade, like a 12-inch, 1/8 inch, 12 by 12 by 1/8 inch will run you about $200.
Wow.
So yeah, a whole sheet of it, a whole sheet is 800. So it's also extremely soft too. I was surprised the graphite's extremely soft.
Well, most graphite you see is what, like a pencil or something. Most people you only know that.
Yeah, that's a very hard graphite. It's mixed with other materials with it, but pure graphite, what I have, is actually quite soft.
Let me ask you something on a total different topic. Have you ever used Shugtite? I think is the name of it. Shugnite.
Shugtite. Yeah. Yeah, I know. Actually, a friend of mine actually uses it to build his RF blockers.
Okay.
So he's out in Morocco. He's actually a good friend of mine. Actually, he lived in the States for quite a few years. Him and his wife moved out there because they were getting suppressed on some of the stuff they were working on. So they buggered off to Morocco. They've been there about, I think, 5 or 6 years now. So I'm in correspondence with him. He works with a lot of nanomaterials as well. Makes a whole line of RF blockers, keychains, necklaces. He makes pyramids and a whole bunch of stuff that you can put under your pillow to protect your body from RF interference going to sleep. So yeah, he works with the Shugnite quite a bit.
Shugnite.
Yeah, I'm not talking about the wrapper. Yeah, we're talking about
Yeah.
what's that other stuff? The real colorful stuff that's magnetic. That's a rock.
Magnetite.
What's the B? I keep forgetting the name. Something right, pyrite. I don't know what.
Pyrite?
No. What?
Barium?
No.
Magnetite?
No, it starts with a B.
It's really, really colorful, and it comes out in like squares. Okay. Bismuth.
Mm-hmm.
Bismuth, yeah.
Bismuth.
Bismuth. Yeah.
Have you guys used that one?
No,
I have some. I never used it for anything.
You magnetize it at all or anything with magnets with it, Mike?
I mean, I heard that you give it a magnetic, you give it a north and it projects a south.
I've never worked with it personally.
That's what I heard. It inverts the polarity
It's weird in
of
the
whatever
last 2
field you
years.
presented.
I got to check that out. That's
That's
something
what
on
I
my bucket
read or
list
heard.
to get done.
It's kind of weird in the last, since I've been working on these battery cells, I've like turned into like an alchemist. Something like that is totally out of the direction I was originally going in. But it came obvious to me, if you can make a power source that created power for an excessive amount of time, that's the way to go. Now, what kind of sparked this whole idea was the Oxford battery. It's a battery that was made 179 years ago, and it's still in operation today.
Really? Oh, I didn't hear about that one.
The Stubblefield battery is galvanic. It uses galvanic
Well,
principles, but
it's a galvanic battery. They use silver, manganese dioxide, and a cardboard sheet. And what was the other one they used? Silver and copper. Silver and copper.
The Stubblefield
just
coil?
stack. No, not Stubblefield coil. This one's the Oxford battery. You can look it up online. There's a picture of it. So it's been producing power for 179 years. When it was first built, they predicted it was putting out about 2 kilovolts of. It created basically electrostatic field.
2 kilovolts.
So it's like an electret type. So, and after they built the battery, they actually soaked it in beeswax to seal everything together.
Okay.
And it's been in operation for 179 years.
Really? Well, check that out.
I have it up on my stream if anybody wants to take a look at it, what it looks like.
Silver and what else, Mike?
Silver, copper, manganese dioxide, and like a cardboard separator, and that's it.
Yeah, none of those corrode each other that I know of.
Yeah, that's why it's lasted so long. So that kind of sparked the idea of what I'm working on today.
Silver and copper.
Yeah.
Interesting.
I wonder if that's it.
Well, didn't they use that in the Baghdad battery or something? Copper.
They could have, but the Oxford batteries quite.
I think maybe the manganese dioxide was used to protect the copper from natural oxidation.
Yeah, it's slow. Yeah, it slows it down. Yeah.
And the silver was fine with that; didn't need anything.
But I think because it's all sealed up with beeswax, it's also the reason.
Well, silver doesn't really oxidize.
Right.
But the copper will.
Right. So having that beeswax surrounding the entire battery, I think really add to the lifespan. The interesting little battery.
I didn't know that manganese dioxide can prevent.
Well, if they lock it in there, it can't oxidize, right?
Yep.
It's
all about keeping the oxygen from touching it.
I mean, it's not growing because it can't oxidize.
So we're going back to what I'm working on, where I'm trying to control that. Therefore, my battery should last 5 to 10 years. That's what I'm predicting, anyways. Myself, it's actually not a battery at all. A battery stores galvanic power. Mine doesn't have really a capacitive value in it. It just keeps producing potential.
Yeah, you got a chemistry experiment wrapped in there. That's what you got.
Yep.
It's not just 2 plates going together. That's for sure. It has to match in how they balance each other, or not balance, I should say, each other.
Yep. Like I said, I've turned into like a chemist in the last, year, researching all this stuff, alchemy, figuring out, what oxidizes fast, what doesn't oxidize, how can you retard the oxidation phenomena. It's everything. It's just material science. That's what this whole battery is about.
Electrochemistry is what Martin Fleischmann and Stanley Pons were doing experiments with when they discovered cold fusion.
Yeah, exactly. Because you're working at the nano level.
So let me ask you
Mhm.
this. We got copper pipes, right? The negative from all of our stuff goes on to usually the copper somewhere. It's grounded out.
Yep.
Do you think that's getting a little bit of surge going into it to kind of clear the pipes once in a while?
I think so. Well, they've always used copper pipes, in the older homes for plumbing, because it also has a no antibacterial aspect to copper. It kills certain bacteria. Now, because copper is so expensive, they're all switching to plastic, which is absolutely the worst thing to do. Their claim is, oh, we don't want to use the copper anymore because we're using, the lead um, uh, flux to solder the pipes together. That was the big scam of it all. You can fuse copper pipes different ways other than using lead. You know what I mean?
Yeah.
But as far as like an antibacterial thing, yeah, the copper is excellent for destroying bacteria in water.
Gotcha. Interesting.
Yeah.
I like chemistry.
Yeah, it's interesting. I never was really into it, and then I started dabbling with these battery ideas and power cell ideas, and it's just like it opened up a whole new realm, a whole new rabbit hole.
Yeah. Well,
But
they get me
it's
anytime they blow something up. So when they start putting what is that little not Rolaids or whatever they put in there, Altoids or whatever into the
the
soda.
Mentos.
Yeah,
the
they just started
Mentos.
blowing. They got
Mentos.
me.
Yeah.
That was it. If they just had a class on that kind of stuff, I'd be all into it.
See, that's
Anything
why
to get the reaction.
that's why the battery technology that's out there right now is kept it so cheap, so everybody would just keep using it. It's a consumable, right?
Yeah.
Duracell and Energizer, you're making billions of dollars a year producing batteries. Well, how about if you had a power cell that never ran out?
So I was reading the
So
Practical Guide to Free Energy Devices, and it emphasized that we're making batteries in the wrong shape, and the simple
they are.
fact is, energy doesn't travel in a straight line, but we have these straight line designs.
Yeah, it's totally wrong geometry. Batteries should be built like two plates put together. That's how they should be built.
That's interesting.
Not,
Yeah, that's really
not circular. That is the worst way.
Well,
yeah,
they got to
that's
get your
interesting.
money somehow, don't they? I mean,
Well, Duracell and Energizer. I'm thinking to myself, I was talking to my buddy there, and I'm going, they had to have known about this technology. They've been
they
making these
did.
batteries. They did, and probably tried to suppress it. But you know what? The great thing about the internet is you can only keep a secret for so long.
Exactly.
Right.
Right. Once it's out of once the cat's out of the bag, you can't put it back in.
Yeah, and that goes for many things, not just this.
Yeah.
Over Unity devices, perpetual stuff. I still believe perpetual
Antigravitics.
Yeah, it's out there. It's just a matter of putting it all together in one package and making it work, right? But sometimes I think the technology surpasses what society's willing to accept.
Yeah, for sure.
You know what I mean?
I agree with that 100%.
like we could add this free energy stuff 100 years ago, but people didn't want to accept it because academia was designed to keep us from the actual truths of what is possible.
You can get 10 times the energy out of one solar panel by not sending solar energy straight to a battery and instead use a pulse motor and spin up a flywheel. It's the most obvious thing. I don't know why everybody's not just taking a solar panel and running a flywheel to generate power.
Well, I've actually did that. I've done that with. I put a 1.5 kilowatt inverter up to a battery, hook up my pulse motor to it, and
No, I don't mean
inverter
an
I have-
inverter. I mean, sending the solar power to the battery is the wrong way, is what I'm saying.
Well,
I'm saying send the solar power energy to a pulse motor, spin up a huge flywheel, generate alternating current. Then send it to a battery if you want. Whatever the house doesn't use goes to the battery.
Solar panels are obsolete. And
Not really, because you could run
they're obsolete.
a generator with them.
The amount of power that you get per kilowatt out of size is about 30 times lower than what the original solar cell was. When it got patented, all of them, they were told by the patent office they cannot exceed over 20% efficiency.
Yeah, that's like the limit.
Yep. They gave a limit.
Well, why are they researching perovskite technology now to get to a much higher efficiency?
Because Section 113 of the U.S. Patent Office Code states if the U.S. military-industrial complex deems it as a national security, they can deem it non-patentable. They can seize it. It's happened time and time
So you're saying
again.
private companies can still research it, but they'll lose it.
They can lose the right to sell it. Yes.
To sell it.
As long as it is under 20% efficiency.
What's up with that, man?
It's called rigged. That's what it's called.
What do you call it?
It's exactly. It's rigged. The game is rigged. It's not
The game is rigged.
The
game is rigged. It is.
You have these energy monopolies and their whole existence. Yeah, there's basically 3 companies that run the energy market, and they're subsequently the same 3 banks that run our economy. Their whole existence is predicated on.
I'm just saying, you could take that 20% efficient solar panel and make it 100% by running a pulse motor with it and turning that into alternating current instead of sending it straight to a battery as we're doing now.
Yeah,
but now that the answer seems obvious now, but I think the problem is like conventional science is saying no, that's not possible. So nobody's looking in that direction. What
do you mean?
We have to
remind up a generator with a pulse motor and use the solar energy to do that,
and produce more than 20%.
Honestly, the way
with a flywheel.
Honestly, right now, the way I see it, solar energy to me is obsolete.
It's some kind of power.
It's obsolete because there are technologies that can replace solar and wind. My power cell doesn't need.
I mean, I guess it does still serve a purpose, though, in a way. Even if it was obsolete, I think in certain situations.
Yeah. For small things like calculators and whatever, small devices, okay. But I'm serious. I'm being dead serious with you.
Hey, I want to bust out my laptop and have I want to have a solar panel strip on my laptop. That's what.
Like honestly, the way I look at it, solar panels on the top of a roof of a house look totally retarded to me.
Yeah.
Because I know no, they do. They look absolutely absurd.
I live in California. They got them everywhere.
I know. I've been to California. I know.
Yeah. They just changed the building code, and there they go, man. They just got every new house has to have.
It's funny. You can waste all that money on the solar. You could waste a bunch of money on solar panels, and they won't yell at you for hooking it up to the grid. And you hook a rodent coil up to the grid, and they'll hunt you down.
They have no idea how to calculate it back into the grid. Let me just tell you that right now. Whatever system they're using is complete BS because the bill itself, when you get it, it just looks like garbage time. Like
so, as long as I split the circuit breaker in a certain way, as long as I split the power in a certain way, and they still think I'm using their power a little bit, I could trick the system, huh?
Yeah, I don't know about that, man. People get in a lot of trouble for messing with those units.
Oh, I know.
Oh, yeah.
As soon as you hook something up to the grid.
It's a grid
Oh,
tie
I seen.
inverter.
Oh, I know what some guys used to put huge neodymium magnets right on the side of the meter.
It was
it
slow
worked. It
from
worked.
spinning, right?
Oh yeah,
Yeah.
you know when you had the old Westinghouse meters, they were great. You just put a big ass neodymium right on the side of the meter. You watch your
Your amps will still
kilowatt
go through,
hours.
but the wheel will have trouble spinning.
That's right. You know, watch your kilowatt hours go down by 40%. Yeah.
I still
See,
have
To
one of
me,
those
I would
meters.
think they would see some kind of noticeable difference and be suspicious.
Oh yeah,
But I don't know.
People-
Maybe they
people-
won't.
Oh yeah. When the guy comes around to read
They
the
would.
meter and sees a giant neodymium on the side of the box, they're kind of screwed after that point.
Do it to heat your pool and then be done with it. You know what I mean? Take it right back off. The meter guy comes on Thursday. Don't do it on that day.
That's right. Just figure out what his schedule is.
Yeah, no. One of the first rules I set for myself is if I ever built an over unity system, I wouldn't hook it up to the grid.
No, that's the worst thing you'd
Why
ever
would you?
do.
You
Yeah,
wouldn't
that's
have
the
to.
worst thing you can do.
You
Well,
can-
exactly. But I'm just saying that's a mistake that some people make. Like John Searle, he made the mistake. You know what ended up happening? He had to pay like 10, 20 years worth of back taxes or back pay for the energy company.
Yep.
They,
Yep.
they
Dude,
saw
that's
it. They're
the
like,
thing.
we can't figure out how this works, so we think you're stealing it.
Yeah, the best thing to do is just write them out of the equation altogether.
Yeah.
They're not to be trusted at
Just-
all.
Hey, just use it in your garage lab setup and you're good to go. Leave everything
Yeah.
else normal.
Well,
And that's all I wanna
what you
I
do,
wanna experiment
what you
with this.
do, what you hook up is that breaker box. Say you got, I got a gas generator. I want to hook it up to the house. Can you guys put in the breaker box so I can, separate the mains from my generator?
Yeah.
And after they do it for you, you pull out your over unity device, shut your breaker off, turn your system on, and there you go. You're laughing, and you did it legal too.
Oh,
They don't have to. They don't have to know what you're putting in it. Just say you got a UPS system.
Yeah.
That's it. That's all you got to tell them. I got an
Oh.
auxiliary battery backup system. I just need the breaker switch to shut off the mains and patch my system in. It'll cost you $3,000, but you get it done legally.
just put it. You guys just put it in the closet and lock the closet. There you go.
That's it. That's it.
Just hide it
Put
away.
it in the attic.
Well, they can't see it right away.
Yeah.
Make them search for it.
But you could use it during peak hours and at nighttime. If you have to, do laundry or use heavy utilities, you just go back to the grid, use it for a couple hours, and shut it off and go back to your system. You
Oh,
probably
man.
save like 50-60% off your utility bill.
That whole peak
Right.
hours thing drives me nuts, dude.
Well,
It doesn't
It's a
cost you
scam.
any more to make the energy, and if your grid
Right.
isn't good enough,
Yeah.
go pay. We pay you enough. Go fix it.
Exactly, Nathan.
That the whole thing BS. And I don't mind if they just told me, hey,
I
we're
think I
just
know
going to
what the
charge
problem
you
is
a
with the
service
grid.
charge so we can build the system out so that we can do things. I'm okay with that.
I think I know
Just
what
don't
the
lie to
problem
me
the
and
grid
tell
has.
me it's because more energy usage. Just dude, get out of here with that.
Check this out.
Yeah.
You guys talking about peak hour usage and billing?
Yeah.
Mm.
People
Yeah.
with solar systems and battery banks, if they're smart, they'll charge up their battery bank when the peak hours are not
Mhm.
occurring. And the
Yeah.
grid don't like that.
Yeah,
it's
that's
true.
Yeah, that's
Yep.
interesting.
You just got to know how to play
Because
the game.
you screw up their power regulation by
Yep.
You screw up their bank
Exactly.
account is what you're doing.
it's like you're deciding when the peak hour is now by draining the system.
They don't care. They got the same amount of energy no matter what.
No, they don't,
Yeah.
because if
Yeah.
you're charging up your battery banks, like everybody that's smart enough to charge their battery banks when the price is cheap at certain hours of the day, well, that's going to really piss off the grid because they're expecting to do something with the grid as far as power regulation goes that completely opposes what everybody else is doing by
It does nothing to them, Mike. It just all it does is increase the demand on the system. That's all it does.
No, I mean the grid actually has to dump energy here and there.
Yeah. But
They can't slow down the nuclear power plant. They can't slow that down or turn it on and off. They have to dump power when it gets built up too much. So they'll make the power cheaper to get people to use it. If that don't work, they'll throw it out.
No, what they do, like here in Ontario, our excess power goes to the U.S.
There you go. They got to get rid of it somehow, or your transformers will start exploding.
No, it's true. The one that's in Quebec, just outside of Quebec, a big hydro plant, a lot of that stuff feeds into the U.S. power grid on the East Coast.
Really?
Yeah, so they benefit by being connected. They could exchange their excess, when they need power, and the other guy's got excess. You know?
Yep. We just sell it off to the U.S. per kilowatt hour.
Always making extra money off the U.S., that's for sure.
Well, that's why everybody's in a race for nuclear and what is it, the uranium? Or is it uranium or no? It's,
people always complain about living here, man, but it's like the greatest place on earth, man. It's just
you hear about all they're trying to
a lot more
build
things
a lot
for
of
free
new plants.
And a lot more things going out than you ever thought they would because we got idiots in power.
They're about to build a bunch of new nuclear power plants. There's a huge race beginning on that between not just the U.S. and Russia, but the whole world.
Yeah, they should be using thorium.
Whatever. They're all going nuclear. Yeah. Everybody's going nuclear for their power grid.
Yeah, they have to switch over to thorium. Thorium is way safer. It doesn't have the radioactivity that your regular fission is.
Yeah.
So,
you're going to have to switch. You're right, because thorium's more available, right?
Yeah, it's a way safer to work with.
It's still a joke, a nuclear power plant is still making steam and spinning a freaking turbine.
Yeah, the method of generating power is still 120 years old.
Yeah,
so
it's a joke.
Right, where my power cell is solid state. There's no generators, there's no pulleys, there's no rotors.
That's the ultimate way to do it.
There's no bearings.
Solid state, yeah.
Nothing can wear out other
friendly
than
materials,
Right, and that's the thing that I like to remind people about perpetual motion machines. While the concept might be possible with over unity systems, you still have to consider the degradation of the materials you're working with.
That's right.
Yeah, are you talking about magnet machines? Is that perpetual motion when you guys say that?
Any kind of perpetual motion. There's many kinds of, but yeah, in general, just any kind of perpetual motion, something that's supposed to just go on forever and ever and ever and ever. Well, the concept behind it might exist, or work.
Well,
what's it made out of,
Well, see, like right now, a hydroelectric power plant is a perpetual motion machine.
That's what a plasma does. Plasma energy does the same thing. Plasma energy is perpetual motion.
That's true too. Yeah.
So for them to say
in a vacuum and it's running, then it's probably going to keep running however it got started.
So for academia to say that perpetual motion's impossible, look at Niagara Falls. There's one right there. How long has Niagara Falls been falling? Millions of years. Millions. And it's going to fall for a million more years. There's your perpetual motion.
Mike, we talked about this before about the Warren, Tesla, or someone was doing something with coils and generating a field and then moving the coil and the field was still there.
Well, with Tesla or
I don't know. We had a discussion about that.
Oh, what about Steinmetz fixing
about how you can run a frequency in one location with a frequency generator, a coil, whatever you're using.
Yeah.
Move it away, and this frequency it stays there. It's like established now in that location.
Yeah, as long as the two coils have the exact same geometry.
That's your perpetual motion plasma effect.
I wonder if that's some sort of magnetic synchronicity.
You're creating a plasma field in that location on the planet. If you're generating a frequency that's resonating with that planet that you're on, wherever that transmitter's sitting, and you let it run long enough, just like a self-oscillating coil, you know.
Right.
It's you stop spinning the rotor, or you move the coil away, and it's still oscillating in that location because you created the oscillation in that location.
Hold on.
Kinda
If
like-
you set up
Right.
something with the frequency of the Earth, you would have it blow up. Like it couldn't handle the amount of potential going into it. I don't think.
No, you would create a harmonic resonance, and then the plasma would form. The plasma, it has to be some type of a plasma resonant frequency that's generated off of your signal and combination with
You
your
have-
signal to generate a third signal that becomes a plasma signal that then remains active and stays there without your transmitter, but probably requires the planet.
Okay. Harmonic resonance to create plasma.
I mean, these experiments have been done, and
Do you have a link to that?
Let's
no, I
the
don't. I
star
heard
in the
it
jar
somewhere,
experiment. Yeah, the star in the
Guys,
jar
I'd like-
experiment. Here, I can show you.
Guys,
but- What'd you call it? What'd you call it?
The star in a jar experiment. It's where you have. Excuse me. It's so you have a vat of water, and you use ultrasonic frequencies to induce bubble cavitation. That creates plasma.
Oh, well, that's sonoluminescence, right? That's plasma also.
sonoluminescence. But there are many
Guys,
different ways to induce the cavitation.
Guys, I got to take off here. Thanks a lot for having me on.
Oh, thank you for coming on.
Oh yeah.
Yeah.
Thanks for coming on,
Yeah,
Mike.
yeah. We'll see everybody on Friday night.
Okay. We'll see
Sounds
you there.
good.
Okay, take care.
Bye.
Yeah, I mean that's similar to what I'm talking about, but it's a plasma. You know, once the plasma is generated, it's done. It's self. What
I
do you
just
call
didn't
it?
know you could create it that way.
Self-sustaining?
Self-sustaining. Yeah.
As long
You
as it's
said
in
what,
the
Nathan?
vacuum.
Interesting. And I got
I mean,
something
in a
else to look
vacuum.
into tonight. I'll be up
Yeah,
all night studying.
plasma physics is very fascinating. It's something that I've been researching for a little bit, and it kind of ties into a lot of different areas that we're studying, like a lot of different areas of fringe science. Because it's basically microscopic ball lightning. You know, there are many different names for the same things that we're experiencing in these devices, the same phenomenon. My theory is that when you suppress science, you know, you have multiple different people looking into something, labeling it different things, you know, because you don't have a organized way of defining something in the mainstream. You've suppressed it. So there are all these independent branches popping up, naming it whatever they deem fit.
All right, guys, look, it's 6:05 right now here on the West Coast. It's about time. It's been about 3 hours we've been on. So I'll everybody say their, final. Anybody got any live streams coming up that you guys want to promote real
See
quick?
what G wrote there, Ben? Plasma physics is part of what vortexes do. Exactly.
Yes.
You know,
yeah.
It creates the toroidal circulation, and once that circulation is established, and it's in a vacuum.
It's called the fractal toroidal moment. Look that up.
Gotcha.
I believe vacuum has no resistance or nothing to
I'm
stop
not sure.
the-
That makes sense though. Oh, I did have a plug. Assuming, and this is all based on, you know, when the second coil frame gets here, but I'm having the workshop for the coil on Sunday. And if I need to, I'll push it, but I want everybody to get ready who wants to participate in that. I'm going to have a class on how to, you know, wind and connect the Rodin coil. So you all who are interested can work with me and build your own Rodin coil systems.
Right on. That'd be cool.
Yeah,
That'll be an all-day
and a standard
class.
coil is also toroidal, you know. Like a standard spiral coil is also generating a spiral.
Correct.
Yeah.
You know, we see toroids a lot in nature, like from the galaxy spirals, you know, DNA, lots of things just kind of form that natural pattern.
Probably not the most efficient spiral, but the vortex the vortex coil is probably a different type of spiral,
Mhm.
geometry or whatever. Maybe more compressed to the thinnest point of the vortex is probably most compressed.
All right, guys, I'm going to end this stream. Mike, thank you very much for coming out today and talking us
Yes,
through
sir.
this
Yeah,
whole
thank-
Bedini thing.
Thank you,
See you
Mike. This
guys.
was awesome.
And
It
we're
was
always
good-
open
it was
for
good.
more questions on the switching circuit there. And
Yeah, definitely. I'll be in touch for more on that. And I really appreciate you guys for coming on, and Nathan for putting together this amazing live stream for us. This was an awesome show. So I'll see you next
Right on.
Monday, or Friday, and then again next Monday.
Yeah, I'll see everybody on Monday for the live. We're doing another one next week.
see you guys Friday.
We haven't quite worked out exactly what we're going with yet, but it may be the gravity flyer, maybe something else that we're doing, another coil. Either way, man, totally cool with it. So,
All right, guys. It's been fun.
all right, guys. See you later. Have a great night. Thank you guys for tuning in.
Yeah, thanks. Good night.